Actually, both sources are used to form coordinated time.
And they take the average.
And them and many other clocks.
Okay, well, I think that average is now at 1:30, so
Go right ahead, Andy.
let's go ahead and get started. So welcome to everyone to the 2021 annual program review for the NOAA University of New Hampshire Joint Hydrographic Center. I'm Andy Armstrong. I'm the NOAA co-director of the center. And the purpose of our review today is to present the center's work to our government sponsors and partners. And in addition to our primary Office of Coast Survey sponsor and our other National Ocean Service partners, the National Geodetic Survey and co-ops, we're pleased to welcome our supporters from the Office of Marine and Aviation Operations, from NOAA Research, and the National Marine Fisheries Service, as well as the Navy, the National Geospatial Intelligence Agency, and the U.S. Army Corps of Engineers, and our good friends from the Canadian Hydrographic Service. So thank you all for joining us. This afternoon, Larry and some members of our research team will share with you some of our research and educational accomplishments of the past year. And so at this point, I'll turn it over to Larry.
Well, thank you, Andy, and let me join Andy in welcoming you all. I certainly wish this could have been done in person, and I hope very much that next year it will be in person, but we'll do the best we can. This is, I think, as you all know, quite an abbreviated session this year. Instead of our two days, we'll have the couple of hours now, 3 hours maybe, of presentations and discussions, again, abbreviated to our government colleagues, and then tomorrow we'll have a 2-hour session with our industrial partner. And the part we're really skipping is that interchange, that overlap between the government folks and the industry folks. And I think we wait till next year till we're all a little more directed in which way we're going to do that. As I said, we're going to just do a brief overview. I'm going to give in a few minutes an absolute lightning presentation. You're going to have to put your seatbelts on and try to go through all the different things, not all, many of the different things that we're up to over the course of the year. And then we'll have just a few, 3 more in-depth presentations on several of the key projects. Let me just flip to the slide, which shows you what we hope to do in terms of this afternoon. In the next step, I'll talk about the dedication of our conference room in honor of Rick Brennan. We'll have a welcome from Katie, a welcome from Paul Schatz, who's the Acting Deputy Assistant Administrator of NOS, and then we'll go through our talk. We'll have a little break. I hope we'll be on time for that. And then after that, 3 presentations, one by Val from Goss, which is a warehouse where we're setting up the new DRIX USV. We'll have an update on some of our water column work and a very exciting new undergraduate course in ocean mapping we're offering from Liz Widener, who will be offering that course. And then Chris Christos will be presenting an update on the cartographic activities. And then hopefully we'll have at least a half hour for some QA and discussion. And to be honest, we can stay on as long as you're interested if the questions go beyond that. So with that, let me turn to something that, let me actually, a little protocol. We are using, for the most part, for the non-government folks, we're using the regular Zoom meeting, which means anybody can interrupt at any time. So we're going to ask you to basically keep your microphones muted. We can use the chat for comments or questions. You can raise your hand with the raised hand function, or you can interrupt if you want. That's really not a problem. But please do remember to keep your mic muted if you don't want to interrupt. If there are technical issues, you can email Will, who's monitoring what's going on, or there's even his phone number if it's something that's more of an emergency. So
I'll be monitoring the chat as well. So if you just have something you want to bounce off of me in session, just let me know.
Well, that's great. Thank you, Will. So with that, let me, as I mentioned, go to something that I never envisioned that I would ever have to do. and that's memorialized the passing of one of our students. To me, it's much like a parent outliving one of their children. It really just shouldn't happen. I think most of you know that Rick was among the early graduates of our program. I don't think any of us who were around at the time will forget those days. Rick's keen interest in all that was going on, his constant questioning, sometimes arguing, but always challenging us and forcing us to think carefully about what we were saying, what we were doing, and why we were doing it. It was clear, I think, from day one that Rick was destined for great things, and he certainly didn't disappoint us. Throughout his career, he was a wonderful colleague and a wonderful friend, both personally and to the center. And we're very grateful that Senator Shaheen recognized and honored Rick by reading a statement into the Congressional Record on the 25th of May, honoring Rick. And if you've not read the Senator's statement, you should. I really encourage you to do that. It captures many of our thoughts and memories of Rick very, very nicely. And we're going to include a copy of Senator Shaheen's remarks in a plaque that will be mounted in honor of Rick in our conference room. Rick's death was a tragic and unimaginable loss to his family, to Tracy, Ty, and Sam, whom he absolutely cherished, to CCOM, to NOAA, and to the nation. He had so much more to contribute, and we will all deeply miss him. But we hope to preserve his memory and have his legacy be an inspiration to all those who come to CCOM. And so on this 14th day of July, 2021, I hereby declare that our conference room, which for some obscure reason we've always called the Admiral's Conference Room, from now on will be the Rear Admiral Rick Brennan Conference Room. And I hope that in the future, many of you will come to meetings in this room, and in doing so, share in our memories of Rick. And I wasn't sure I was going to get through that, so, but I'm glad I did. And let me now just turn to introduce Katie Reese, who for many years has been the Deputy Director of the Office of Coast Survey and is now serving as the Acting Director. Katie, let me turn it over to you.
Thank you very much, Larry and Andy, both, for hosting this virtual event. And I do share your sentiments, Larry, about hoping that circumstances next year will allow us to resume this meeting in person. And I want to express on behalf of NOAA how touched we are and how much we appreciate your dedication of the conference room to Rick Brennan, that you are doing this in his memory. And as you mentioned, both as an alum and then throughout his career at Coast Survey, Rick had a very strong connection with the work that began in a large part with the time he spent at the Joint Hydrographic Center. At his memorial service, in fact, it was noted that when Rick was working on his degree there, that he was absolutely in his element, that he was so stimulated and captivated by what he was learning. And then he went on to infuse that absolutely passionate enthusiasm about the importance of hydrography throughout the rest of his professional life. And certainly as the Coast Survey Director, as short as that tenure was, the relationship with UNH and the Joint Hydrographic Center was a high priority for him. And the Joint Hydrographic Center is a long 22-year partnership between NOAA and the university, which has greatly benefited both organizations, and I think serves as a model for effective government and academic collaboration. And as Andy noted, this is also an important element not only of our partnership with the JHC, but also with our NOS colleagues in sister offices like co-ops and NGS, as well as with other parts of NOAA. And the uncrewed surface vessel development that's going on at JHC right now is a prime example of that kind of all NOAA and cross-cutting work with UNH, that kind of teamwork that has evolved from this partnership. And the Joint Hydrographic Center has had a long-standing role and will continue to have a very important role in the advanced education of our workforce. A priority of our new NOAA administrator, Dr. Rick Spinrad, as well as for Coast Survey's workforce and professional development. And one of the best ways that we realize this objective is by having Coast Survey personnel spend 2 years working on their advanced degree programs at UNH. Many of Coast Survey's leaders have come through the program and then remain with the organization because of their commitment to the mission. And this is no better exemplified than by someone with the caliber of Rick Brennan. So thank you again for your tribute to him. Thank you again for inviting me here today. I think Rick's legacy will continue to be carried out by those that continue to come after him and those of us that are still here. And I think he's great to see us all moving forward, continuing to move forward together. So I look forward to listening to the presentations and hearing about the great work that has been done this year. And now it's my pleasure to introduce the Acting Deputy Assistant Administrator for the National Ocean Service, Paul Schultz.
Find the mute button here. Thank you, Katie. Good afternoon. I'm Paul Schultz, Acting Deputy Assistant Administrator for the National Ocean Service. I'd like to thank you all for the opportunity to be here today. And a special thanks to JHC leadership and staff, especially the co-directors Larry and Andy, and all the staff for putting this event together and all the work that you do every day. JHC, as Katie mentioned, has been a trusted NOS partner for more than 20 years, and their contributions to the hydrographic and ocean mapping technologies have been extensive. I look forward to hearing about the JHC's accomplishments from the past year, and while this may be shortened, and for many of you that will be bad, this fits within my schedule, which is a little crazy these days. I'd like to give a couple of leadership and budget updates. As Katie mentioned, we are very excited to have Dr. Rick Spinrad on board as a new NOAA administrator. Rick has a long history with NOAA. He was NOAA chief scientist in the Obama administration. He also served as assistant administrator for both the National Ocean Service and the Office of Atmospheric Research, Oceanic and Atmospheric Research. We look forward to his leadership. Rick is very familiar with JHC and CCOM, and we look forward to bringing him up to date on the work done here at UHC since he left NOAA a few years ago. During his confirmation hearing, he outlined his priorities for NOAA as climate, and specifically around the implications for communities, blue economy, and the workforce, as Katie mentioned. The other leadership update I wanted to mention, which is hot off the presses, is Ms. Nicole LaBeouf is finally installed by Secretary Raimondo yesterday as the National Ocean Service Assistant Administrator. This has been, believe it or not, 3 years in coming, and it stands us all in good stead. She's been acting for that entire time, and for many of you who may have interacted with her, she's a force to reckon with, and actually very supportive of these activities. The administration priorities most connected to NOAA are focused on alternative energy, climate change, coastal resilience, and racial equity. These are reflected in the FY22 budget that was released on June 25th. Wind energy in particular and coastal resilience are areas where hydrography and ocean mapping play a critical role. At NOS, we particularly appreciate the need for new technology to increase the efficiency of our hydrographic and coastal mapping programs and look to JHC as a primary innovator in those missions. The FY22 President's budget for NOAA and the National Ocean Service was particularly strong this year, particularly after the last 4, with more than $180 million increase over the FY21 enacted budget. These funds are primarily, I think it's 145 million, are going out as grants to states and local governments for place-based management and understanding and becoming more prepared and resilient for storms, flooding, and inundation events. Regional observations and data management, coastal modeling, as well as a few others also received some increases. In addition, the president's budget continues to show strong support for the JHC with an increase of $1 million over last year's request. Thank you again for inviting me today, and I look forward to the future of our partnership. And I know we can continue to accomplish great things together. Turn it back over to you, Larry.
Well, thank you so much, Katie and Paul. We really appreciate your words. We're certainly delighted to hear about the appointment of Katie, excuse me, of Nicole. You're absolutely right. That was a long time coming, and we're happy to see that happen. And I think, as Paul described, there are many, many good things happening. A year or so ago, there was a White House workshop about ocean issues, and Margaret Lynan, the director of Scripps, made the comment that the oceans are really having a moment. And I think that's so true. And I think hopefully we at the JHC and all of us associated with NOAA will ride on that wave and do great things. So let me turn back and start to share my screen again. And let's see if that all works and we can get back to the slides. Please, somebody let me know if you can see that. Is that
That's
Looks
good.
good,
Larry.
Larry.
good? It's in presenter mode and everything is okay?
Yep, looks good.
Okay, great. Thank you. Okay, and so as I said, this is gonna be kind of a lightning presentation. I'm not gonna give you any detail on anything really. It's just the concept here will be to let you know the kind of things that we're doing and who's doing it. And so if there is interest to pursue any of these topics, we'll follow up with 3 in a little more depth, and even then there won't be enough time to go into great depth with them, but you'll know who to contact. You can always contact Andy or me, but the names of the folks who are leading these efforts are going to be listed, and please feel free to contact them and set up any kind of more in-depth discussion you want with them. I know many of you know the history of the center, but for those of you who not, I'll just briefly review that we did start almost 20 years ago with a small little earmark from Senator Gregg. And since that time, we've long been weaned from an earmark, and we've grown and grown and grown, both in number of people and physical space, with a number of additions to the physical plant, so to speak. In 2010, we started through a process of competitive awards for the center, for a joint hydrographic center, not one at UNH, but just a joint hydrographic center. Through a federal funding opportunity. And in 2010, we won that award. We were delighted that we won it again in 2015. And then in 2020, we recently now have gone through a new competition. And again, I'm delighted to say that we have been awarded that. And so we are in the midst of starting a new grant effort, what I'll refer to mostly as the new grant. That's the grant from 2021 to 2026. But the old grant, the 2015 to 2020 grant, has a 1-year no-cost extension and part 2 to COVID. And so we are actually doing things on both grants at the same time. And when we do our formal reporting, this presentation is no longer, it used to be the formal 6-month report for the center. It's no longer that. That's been replaced with the standardized RPPR that NOAA and other federal agencies are using. So when we do that formal reporting in a few weeks, we will separate the efforts on the old grant and the new grant quite clearly. But in this report, I'm just going to let you know what we've been doing over the last year, and there'll be some mixture of old grant and new grant stuff. And I don't think it should concern us too much. Since our inception, we've had a fairly constant set of goals. We haven't deviated from this, and with the hope of being a world leader in the development of hydrographic and ocean mapping technologies and approaches. And we've always had this other aspect of expanding the scope of ocean mapping clients and constituencies through the development of innovative applications and collaborative work with both the private sector and government labs. And in that, what we've recognized from day one is that the data that NOAA Coast Survey collects in support of safe navigation, which is such a critical thing, but those data can also serve so many other applications. And we've worked very hard to demonstrate these other applications and how valuable that data that's collected in support of safe navigation could be to many other things. And so with that in mind, and with our desire to make sure that our students and our faculty and staff are really up on what's going on outside of just the academic track and outside of the government perspective, we've established since day one a group of industrial associates, and I'm thrilled to see it's grown to 58 of them now. Most of the companies that operate in this sector have an association with us, and some of them take really lots of advantage of it, and you'll hear about some of those interactions. Others don't, but that's up to them. And we're just thrilled to be able to interact with them, learn what their needs are, and again, that's part of what we'd be doing tomorrow. And in the future interactions, we'll have that overlap with NOAA, so NOAA can learn those sorts of things also. Along with those goals, we've also had educational goals, and our mandate to educate a new generation of hydrographers and ocean mappers that can meet the growing needs of both government agencies and the private sector. And in that context, we have in our graduate program, and we've been a graduate program since day one, a number of tracks that students can enter from the engineering side, from the earth science side, even now from the natural resources side. We have a PhD and MSc program in ocean mapping with all those different input routes. We offer a graduate certificate program, which is a year and a half so program, and that's what our Nippon Foundation JEPCO students get. We've also offered some non-degree programs in terms of short courses, seminars. We've hosted Surf Scholars and Hauling Scholars. Most excitingly, though, a couple of years ago, a Bachelor's of Science in Ocean Engineering program started at UNH. And this has been great for us because it really provides a cadre of students with a really appropriate background that we can entice into ocean mapping, into the ocean mapping field. And we've really enhanced, based on that, excuse me, our interaction with the undergraduate program. And one thing we're starting to do, we will start doing in September, is now offering a special course in integrated seabed mapping for undergraduates. And Liz Widener will be teaching that course, one of our senior graduate students, and she'll talk to you in more detail about that later. So I don't need to say more about that. Another thing we've done starting this year is a summer internship opportunity. We had a competition and selected 2 students, Tom Spiro, who went out on the Fairweather and then went to Thunder Bay to help out there. And Natalie Cook, who's been on the Thomas Jefferson. I think it's still on the Thomas Jefferson right now. And I have to say, this has been fantastic. If you read their blogs, they're having a phenomenal time. They're learning so much. The response we've gotten, and maybe Bree will comment from those on board, has been that they've been tremendously helpful. They've gotten involved in every bit of interaction. And I think we've got at least 2 students now hooked on a career path going in this direction. And I keep thinking that of all the things we've done, this may be one of the most important in terms of really inspiring these young students into heading off into this direction. So this is something we will certainly continue, and we very much appreciate the cooperation of the ships in terms of hosting these students. Also, excuse me, in our education program, we have hosted for the last 17 years the Nippon Foundation JEPCO training program in bathymetric sciences. And this is something we competed for internationally, won the competition, and then do recompete in terms of a proposal almost every year. We're now finishing up our 17th year, where we had students from, as you can see on the left, Venezuela, Colombia, Ireland, Malaysia, Philippines, Russia, and the UK, and the incoming class who should be arriving any day now, coming from the Azores, Denmark, Ireland, Japan, Nigeria, and Sri Lanka. And this has been added a wonderful dynamic and really broadened our network of hydrographic capacity building and colleagues all over the world. We call upon these alumni. They have an amazing alumni organization, and we call upon them all the time to support all kinds of efforts. So we have representation so far from 45 countries and 102 scholars to date. The COVID situation has certainly put some stress on our training program. We've had to move all our courses, and we did move all our courses to online. That was a big lift, but I really commend our faculty for stepping in and doing that. But I think it's also probably a great investment in terms of our ability in the future to be able to maintain some ability to teach online so rapidly and offer online courses. Even more of a challenge to labs that were not so easy. Sema Dykstra in particular developed a number of kind of remote labs that we could work in, but we were able, within the constraints of the COVID regulations, to have small labs outside and 2 or 3 students at a time, bring them on our vessel to the point where we could, even this year, complete our summer hydro program, where the students go out and plan a survey, mobilize, acquire the data, process the data, and come back with this full report. And so they were able to collect new data this year. So we're very happy to see that. I did want to mention, over the years now, we now have a total of about 204 graduates, 102 of those being JEBCO scholars. But if we look at our non-JEBCO scholars, I wanted to point out 18 NOAA students who've come and received master's degree. And for the first time, this is the first time we've reported this now, 2 PhD NOAA students too. And that's with Mashkar Malik and Derek Sowers. So we now have our first 2 NOAA PhD students. So we're very, very proud of them. If you look at the list of the non-JEBCO students, the ones in blue are the folks who came into NOAA, into our program from NOAA. But the ones I want to point out, really, the ones in orange who didn't come in as NOAA people, but left and joined NOAA after the fact. And again, hopefully we're being a feeder pipe for highly trained people into NOAA too. We often hear about the Center for Coastal Ocean Mapping and the Joint Hydrographic Center. These are 2 complementary centers. The Joint Hydrographic Center is the result of this federal funding opportunity. It's a result of the grant. It's the vehicle for the grant. And that's the relationship between the university and NOAA. Mostly Coast Survey as the primary sponsor, but also nice sponsorship from OMAO and OAR, particularly Ocean Exploration, and now and then other parts of NOAA too. But at the same time, we have the Center for Coastal and Ocean Mapping, which is really the university entity. It's the same people, we just change hats and say now we're representing the center, and that lets us stand at arm's length from NOAA and the government, and allows us to get involved with a range of other organizations, both our industrial associates and other federal agencies. And we do get funding from those last year on the order of about $4.5 million in non-NOAA sources. And this is not just last year, this is a list of other people we've received funding from. There are 2 programs that are coming from NOAA that are not part of the JHC that I want to mention. Since last year, we've been a member of the new OER, Ocean Exploration Cooperative Institute with Woods Hole, URI, the Ocean Exploration Trust, and USM. And our focus on that is the delivery of a uncrewed surface system, the DRIX from IX Blue, and developing approaches of using that for ocean exploration. I'm not going to talk much about that now. When you see this little sun sign, it means it'll be followed up. And so Val will talk about that because it just arrived. The OECI DRIX just arrived a couple of days ago, and they're unpacking it now and setting it up over at our warehouse facility. The other major program that we've been involved in is through, again, OER through NOP. And that's a grant with Saildrone and Mabari for the further development and implementation of this remarkable 22-meter Saildrone surveyor with a deep water multi-beam system in it, and a suite of environmental sensors, including eDNA sensors. And so we, through NOP funding, went through a series of seagoing acceptance trials of the new multi-beam system a few months ago. You can see the shallow water system, the deep water systems eventually performed beautifully. And then in mid-June, that system took off from San Francisco en route to Honolulu. You can see some of the data collected here. I'm just showing you an example here where you see the difference between when the vessel is motoring and when it's sailing. And the swath width increases by about 30% because it's so quiet when it's sailing. So among all the benefits of sailing, we also have increased swath width. For the most part, this transit was funded by the Nippon Foundation through the Seabed 2030 project. the idea to pick up unmapped areas, and for the most part, that transit was through unmapped areas. As we approached Honolulu, where there's lots of mapping done, we were able to deviate and pick up small gaps coming into the islands. And just to give you an idea of what that entire transit looks like, the system worked quite beautifully. It came into Honolulu last Thursday. It'll be working there for a little while and then coming back probably to San Francisco a little later. Again, I apologize, you can't be at the lab. We normally have tours around and you see our very nice facilities in terms of telepresence consoles, our training facility, our Viz Lab, which is a remarkable thing to see. But you'll have to wait for next year for those of you who haven't seen it. Okay, so let me get into the meat of this. I mentioned that we are ending up our last year of the old grant work, and we're starting the first year of the new grant work. I said I'm not going to separate them out. The way these grants work, they come through a federal funding opportunity. We respond to a federal funding opportunity. The federal funding opportunity prescribes several very high-level programmatic priorities. You can see 3 of them here in the old grant, 4 of them here in the new grant. And then the FFO prescribes a number of more detailed research requirements. And you see 14 of them in the old grant, 20 of them in the new grant. And in response to those, we come back with an explicit proposal, how we would meet those. And we have outlined that in terms of, in the old grant, 57 or so specific tasks, each with a PI. In the new grant, 47 individual tasks, each with a PI or group of PIs. And I just wanted to point out that particularly at this overarching level, there's not that much difference in the direction of these priorities. As we get down to the research requirements, there was certainly a lot more specificity in the new grant, a lot more emphasis on uncrewed systems, a lot more emphasis on cloud-based things and some more cartographic issues. But for the most part, it's the continuation of the major themes we've been working on. And as I said, I won't divide up old grant, new grant now. It'll be a mixture in terms of what I'll talk about or describe. But again, that will be explicitly separated out in the RPPR. Okay, and I should say that if we look at these 3 programmatic priorities, our 3 more in-depth presentations each one will touch on one of these. So you get a little taste of each of those. All right, so now's the time to put the seatbelt on, and here we go. As I said, I'm just going to be running through what we're doing just to show you the kind of things we're doing and who's doing it. And again, if you have interest or want to know more, just contact Andy, contact me, and we'll set you up with the appropriate folks. The details are presented even after the implementation of the formal reporting through the RPPR. We still produce a very detailed, often beyond 300 pages long progress report at the end of each year. We have one for each year, including last year. And so those are all on our website, and you can go look at last year's, and come December, you'll have one for this year. And this will go through explicitly each one of the projects, the detailed project tasks. All right, so let me start, and I'm going to do this again in the context of our broadest themes. And in this case, we'll start with the Innovate Hydrography theme, data collection, data acquisition. This has been something that we've focused on for a long time, trying to understand the capabilities of the sonars that we put out into the field. What are there limitations? What are the capabilities? Can we calibrate them? Can we advance the level of the information we collect with them? We've invested heavily over the years in creating a calibration facility in the beautiful deep water tank that we have in the lab. And while COVID presented us bringing a number of systems in this year, we did bring 3 systems, all worked on through serious COVID protocols, but we did calibrate a MITRE hydrophone array, an EdgeTech semicircular array, and an IX Blue CPEX system. And I'll talk a little more about that in a few minutes. We not only think about the calibrations in the tank, because calibrating a system in a tank like this can take several weeks. It's a very, very detailed and time-consuming process. And then you go and you move that system onto a vessel. How have you changed it? So Carlo Lanzoni, Tom Weber have been looking for some time at approaches using buoys and spheres of moving a standard calibration approach to a launch system. And we're making slow progress on that. Another approach to the to the same issue, though, is through the use of a chain or extended target. And this is work again of Tom Weber and his students. This chain that you can see in the lower left here, it acts as an analog for an at-sea backscatter calibration target, the seafloor in essence. And so what we do is we bring a calibrated sonar like an EK80, do a standard sphere calibration on the EK80. We then use the EK80 to calibrate the chain, and then we can bring our multi-beam system in and against the calibrated chain, calibrate the multi-beam system. And that's a process of just a few hours instead of several weeks. And so we've been able to do that quite successfully. And here's some comparisons to EK60 spot checks against a calibrated system. And so we have these now calibration curves for a particular multi-beam. That sounds great. One of the issues we found is that when we've taken one of the multi-beams that we've gone through the full several week calibration with, in this case a T50P, and compared to the chain calibration, it has the exact same shape, but it's offset by 3 dB. And we're trying to understand that. And once we understand that, we think we can bring this online to give us an approach to absolute calibration for our at-sea systems in a much more efficient way. Following along those same lines, John Hughes Clark and his students are working on a standardized approach for calibrating a variety of systems in the field. And this is really a relative calibration, but to do this, you need to really understand the response of the system to different frequencies, different pulse lengths, different modes of operation. An example here comes from 3 Rainier launches with data collected over a reference surface in Puget Sound. And this is a method that's been used by OCS for several years now. And what we need to do now is to move from this relative calibration to the absolute calibration, this combination of techniques that we've seen. Further along in terms of trying to understand the limits and the constraints of our sonar system, Tom Weber and his graduate student, John Hamill, have been looking at why we seem to get so much noise in the high phase noise when multi-beam systems are doing phase comparison measurements as compared to, say, a system like an ME70. Here you see that phase ramp is beautifully clean. If you look at theoretical limitations, the ME70 matches the theory just fine. If we look at the theory for the multi-beam, the standard multi-beam system, you see that the actual data is much, much higher than the theory would predict. And so this is constraining our ability to do high quality phase bathymetric measurements. And so they're trying to understand why that is. The thought is that it may be from contributions from outer plane reverberation, side lobe issues, basically. And to test this, they've been working with IX Blue in their new CPIC sonar, which allows them to change the shading of the array on the fly. So they can watch the change in the side lobes and see the impact of that on the phase measurements. So stay tuned for that. Hopefully we'll see if we have an answer there in the near future. Beyond the sonar itself, we put effort into trying to understand the capabilities and limitations of the sonar, but we are also tremendously constrained by environmental conditions. And here John Hughes Clark and his students have been looking a lot at environmental constraints, both in terms of our bathymetry and the backscatter we collect. John is investigating in this example the impact of both Hubble-induced and natural bubble fields, and demonstrating the need to collect and monitor water column information to understand this. And here you see a sensor, one sensor that was on, in this case, the sensor was on the hull blister. There was a deep keel on this vessel. This is the Henry Bigelow. And you can see on the deep keel, it would have avoided many of these bubble interactions if the sensors had been on the deep keel, but in this case, it was mounted on the blister itself. And in that case, leading to masking in the backscatter and mistracking in the bathymetry. And so trying to get a feel for these environmental causes. It's not just bubbles, temperature certainly has a huge impact, and our undersampling of the sound speed variability, leading to a number of unwanted artifacts. Here we have 50 minutes of data collection in Puget Sound again. And we see, due to solar heating, a great variability in the upper 2 to 3 meters of the water column. And that in turn creates a number of false short wavelength topographic features that are actually masking some of the real topography. So again, trying to capture what's going on in the water column and its impact on our bathymetric and backscatter measurements. And the other side of that, John working with Indra, another one of our students, trying to see how much can be pulled out in terms of the oceanography from these water column measurements. So they're using both a multi-beam ADCP and an underway moving vessel profiler to better understand oceanographic variability. And again, once we understand that, we might have better predictions of how it might impact our bathymetric and backscatter measurements. A really interesting sidelight of this is John went back to NCEI's records to look at historic 18 kilohertz EK60 data to see if he can get a feel for the history of the oceanographic conditions, this case in the Gulf of Maine. And sure enough, there was just a beautiful record of oceanographic changes in the EK60. But what he also noticed was that the 18 kilohertz EK60 proved to be a wonderful sub-bottom profiler with up to 30 meters of penetration. And just demonstrating the wealth of value of information that's in the acoustic data we collect and the multiple applications that it can have. Tony Lyons is looking at synthetic aperture sonar, but also finding the important impact of water column structure on the performance of the sonar. And here we have on the left a synthetic aperture image. I think this is a high SAS image, and Tony will chime in if I'm wrong. Seeing trawl marks, and I'm not sure what the dark areas are, but something different on the bottom. 6 days later, the same piece of seafloor, but now appearing totally different. And this is due to the passage of internal waves. And internal waves causing acoustic lensing, creating bathymetric errors by degrading the image. What Tony is doing is trying to model this, and in this case, developed a model that shows the level of degradation, something like 3 to 4 times loss in resolution when passing through one of these acoustic lenses. But the idea being hopefully to be able to eventually do the inverse solution and correct for these effects. So again, this focus on trying to really understand the limitations that the environment is putting on our bathymetry and backscatter measurements. And we go through all this effort. We try to determine all the sources of error in the bathymetry and the backscatter so we can basically come to some conclusion about the nature of the seafloor, its bathymetry and its backscatter. But what if it changes on us? What if it's naturally varying? Well, to take a look at that, Tony Lyons and Jen Dykstra have deployed an array offshore here. It's been out there since mid-November. It has a number of sonar systems on it, calibrated sonar systems. It has a wave measuring CTD and several cameras, a stereo pair and a forward-looking camera. And so already in their long time series, they're seeing that the backscatter is changing as much as 6 dB through several storm cycles. So from this, and as the time series gets longer, hopefully we'll get a feel for what the true temporal variability, the natural change in the seafloor might be, at least in this particular environment. Well, we're also working on tools to try to understand dynamic errors, what we call the wobbles, usually errors that result from inappropriate or poor integration, both from a forward modeling sense, which was Brandon Maggott's MSc thesis working with John Hughes Clark. And he's now on a PhD working with real data and hoping that we will have an analytic tool for analyzing these sorts of wobbles through real data, getting a feel for what the causes of the problems are, and hopefully a direction towards the solutions. The more we do to identify and correct errors during data acquisition, the better off we are. So we've invested heavily in the development in collaboration with the Office of Coast Surveys in a series of data performance monitoring tools. One in particular that's been very successful and very widely used is the Sound Speed Manager, which is part of the HydroOffice suite of tools. It's a very mature application. It's used by thousands of users worldwide. And this year it's been upgraded to integrate with the new versions of SIS and has expanded to incorporate a number of new data formats. Working with our colleagues, Paul Johnson, who has kind of 2 hats on. He's our data manager, also is the PI on the Multi-Beam Advisory Committee, the MAC, which is hosted out of our lab. Again, this effort now mostly focused on deep water tools, but they're just as applicable to shallow water tools, looking at data performance monitoring tools, including tools to monitor system extinction and system data rates, at what rate of data collectors. And the increment this year has been to now allow it to tie into historic data. So when the manufacturer tells you, oh, your system is performing just as it should, you can show them that 2 years ago or 3 years ago, it was performing much better, and that we were getting much better data rates. And so again, really a good tool for looking at the evolution of the performance of a system. They've also distributed tools for creating reference surfaces and for swath accuracy calculations. And finally, a tool that's been put to lots of use, a web-based tool that allows for selecting patch test sites. It provides all the information you need to select a patch test site, the best bathymetry, have slope information, understanding of what the sound speed environment might be, AIS, so you know vessel traffic, a listing of previous sites used and so on. And we've used this and many others have used this to start cataloging and selecting patch test sites. Further along in our data collection arena, we mentioned the new DRIX, which was funded by the OECI. However, the JHC grant has had a significant effort devoted to USVs for many years now, focused on what we call practical autonomy. That's the safe, efficient, effective operation of autonomous vehicles for our purpose. And you'll see that Val is really focusing on our hydrographic purposes in terms of the operation of the vehicles. So Val will report on that when I'm done. And he'll tell you also about operations we just came back from in terms of using our 4-meter ASV in Thunder Bay. What he probably won't tell you, because he's too modest, is that our robotics team entered an international competition this year, where the challenge was to operate a vehicle in a simulated harbor. It happened to be in the Straits of Italy, navigate around all kinds of, identify obstacles and objects, navigate around them. And our team won first place through 13 competitors. And we're very, 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 very proud of them. Something I want to throw out in terms of data collection and gaining efficiency. It's an idea I think I threw out a number of years ago, and it kind of languished for a while. But I think with the new grant, we might start this up and love to get feedback from you. And here we're taking advantage of the fact that our vessel captain is multi-talented. He's also a very talented mechanical engineer. And so Matt has designed small little tow bodies to carry multi-beams and navigation systems. And the idea being that we have from a single launch towing separate on outriggers, separate multi-beams to really increase the width of our coverage. And I think this is probably worth exploring because it could be a relatively inexpensive way to increase the efficiency in shallow water mapping. Along with our data collection, we've also been looking at trusted community bathymetry, and under the leadership of Brian Calder, they've started an intriguing project integrating a very low-cost commercial acquisition system and a low-cost side scan sonar. And the system is designed to autonomously record targets in a given region, convert that to XDF format, and then render it in a variety of ways that can be put into other software applications. Now, in doing this, they're using a commercial logger. It's a logger that costs about $250. And that is not terribly expensive, but you're not going to get a huge, huge crowd. And Brian is constantly reminding us that there isn't often the real crowd that we hope there'll be to make crowdsourced bathymetry as valuable as it could be. And he rather call it volunteer bathymetric information now, because we're getting information from multiple sources that are volunteered, but we don't yet have the crowd. And so what Brian and a group of engineering students have been looking at is how do we truly build that crowd? And one way to do that is to try to lower the cost of things like a data logger, but also to come up with a clear path in terms of a concept of operations, in terms of how we would get data from that data logger into eventually a database. So they've been thinking through that concept of operations involving cloud services, but also been thinking about building a very low-cost logger, and they have done that. And if we can, they have a prototype, it's collecting and logging data. And if we look at the price down here, we see in batches of 5, about $15 each, batches of 50, less than $8 each. And when we start talking about prices like this, these are things you can give away to thousands of people. And we really can truly get the crowd. And again, I think we'll see interesting things coming from this. As we start collecting crowdsourced data, we need to have ways to assess its quality. And Brian is working with graduate student Shannon Hoy on ways of looking at that. They've developed a number of approaches to identifying problematic data, and some are quite easy and some they still are trying to resolve. But there's also the question of the overall quality of the data. And you can a priori say, well, these are people we know and they collect good data. But what they've developed instead, though, is a way to compare the data being collected by the crowd to qualified data. And through that comparison, then determine the reputation of the collector. And that reputation could change and modify as they sometimes do good, sometimes do bad. And based on that reputation, know how we can weight that data into the accumulation from the crowd source. So as they work on that and work on trying to look at different approaches to solving the problems that we encounter, at the end of the day, the plan is to use multiple approaches and a machine learning approach with a fusion solution to converge on the best answer for the data set. And so again, I think this will be stuff taken up in the new grant with some excitement. We're now going to switch from data collection to data processing. Here, for years, we've been reporting on the evolution of Cube to chart Cube with hierarchical resolution techniques under Brian's leadership. We talked in the past about the level of aggregation approach that's been taken, but in the current reporting period, the effort has been focused on the development of distributed computing approaches and a specific implementation with QPS Fledermaus for the new chart approach. With respect to data quality and survey validation tools, we come back to our collaboration with CoSurvey in the development of HydroOffice. Over the years, we've worked with CoSurvey on a range of survey and chart validation tools that are in HydroOffice. And this past year, we've made major improvements in one of the tools called FeatureScan, another called SBDare, a new tool to validate bag products. And at the request of CHS, Genevieve, I hope you've heard that. In response to a request from CHS, we've also put out a command line tool to ease workflow integration. Our data processing tools extend to LiDAR data, and working with Chris Parrish, the CBlue tool has been developed over the years that estimates LiDAR uncertainty. This has matured quite a bit. It's been put into practice in a number of NOAA surveys. And this past year, it's been extended and upgraded to include the Leica Hawkeye 4X. And we've taken ownership and maintenance of the GitHub repository from NOAA IT. And if you're wondering why we had to take it over, you probably have not had the experience of working with a government IT group. But I think those of you who have will understand. Brian and Kim Lowell have also been looking at adopting a chart-based processing approach to Bathy Topo LiDAR data. Last year, we showed an initial effort which used machine learning to try to discriminate between real bathymetry and not real bathymetry, a challenge in Bathy Topo LiDAR. And it showed good agreement with NOAA selected, manually selected real bathymetry. It turns out as that approach was extended, the first efforts were just on a couple of tiles, and when it was extended to many more tiles, we found that the approach actually failed where there were reefs or shallows with channels. And so kind of going back to the drawing board, and a new machine learning method using unsupervised k-means clustering with disambiguation rules was developed. And now we're seeing very good agreement over the full data set, something more than 100 tiles. And so we're hoping we're converging now on a machine learning approach to Bathy Topo LiDAR processing, which will be a big step in the right direction in terms of increasing efficiency. In the new grant, we will be looking at exploring the potential role that ISAT-2 can provide with respect to providing bathymetry. and we'll be exploring the limitations and capabilities of this new instrument over the coming years. We've also extended our efforts in terms of the broader concept of characterization, and now we're entering our characterization theme to understanding the full value of the data we collect in the water column. Tom Weber, Liz Wider, and Alex Padilla have done some remarkable work in terms of much better understanding of what we're seeing in the water column. And fortunately, Liz will talk more about that later, and I don't have to go into that. She'll also talk about Tom and Alex's work, where they have a long-term observatory of a natural seep, an acoustic observatory at Platform Holly on the West Coast. And some exciting things will come from that, learning about natural changes and calculation of flux remotely. With respect to characterization, in this case, seafloor characterization, we've also had efforts that we've talked about in the past, focusing on tools for characterizing the seafloor. We've described the work of Giuseppe Massetti on the development of what we call the BREST tool. This is a tool that extracts from bathymetric data automatically what we call geomorphons. These are characteristic morphologic features of the seafloor. And this past year, Larry Ward has applied this tool and developed other protocols for the analysis of multi-beam bathymetry and backscatter to the identification of sand and gravel resources in the Gulf of Maine. Again, part of the blue economy concept. Again, something we'll carry on into the new grant, I'm sure. On a broader regional scale and under the Explore the Continental Shelf theme of our grant, Derek Sowers has used data that we've collected in support of our ECS efforts on the continental shelf to produce a consistent and reproducible habitat characterization for a good part of the Atlantic margin. This is the first time I think things have been done on that scale. Even more exciting, focusing in on a region of the Blake Tech Plateau, Derek was able to use this approach to identify regions of cold water corals, mapping what's likely the largest cold water coral province ever discovered. And it's providing important input to the South Atlantic Fisheries Management Council. As we zoom in even further, Jen Dykstra and Kristen Mello have been using ground truth ROV data from the Okeanos Explorer to look at the relationship and distribution of various species to the morphology and environmental factors that were collected in there. So we're really getting down to the species level here in terms of looking at relationships. And Jen and Chris Parrish are also looking at the potential of using LiDAR returns to discriminate seafloor rugosity, the roughness measurement, and with that potentially changes in coral reefs. If we move to our transform charting and navigation theme, which really involves a lot of the cartographic efforts we do and our visualization efforts, Christos Kastricios has been very active in a number of cartographic efforts, including automated tools for hydrographic sounding selection validation, cartographic sounding selection, depth uncertainty visualization, data quality, polygon simplification, and a really exciting effort of collaboration with the Maritime Academies. Now, Christos will give you a much more detailed presentation on this in a bit, so I don't have to discuss that more. Further along our charting and navigation efforts, Brianna Sullivan continues her efforts looking at ways of mining textual, it's a hard word for me to say, textual information and converting it into a digital form. She's been working closely with the NIPWIC to develop an approach for a new S100 product for marine harbor infrastructure. And this involves compiling information from publications, translating that into a unified modeling language, and then converting that to a geographic markup language that can be then presented in an ENC. And I think they're up to about 51 features so far that have been going through this development cycle. And again, more questions you can follow up with Brianna. As we move into our visualization activity, Colin Ware has developed a powerful new tool we call Gap Filler that allows us to easily plot routes and surveys in the context of existing data and see what kind of swaths we're capable of collecting. So we really understand gap filling capability. Here we did this for the sail drone route. You can see you can start with a Great Circle route, but then move waypoints anywhere you want. There's both a Mercator version and a polystereographic version, so we can do this up in the Arctic. What you get when you do this, and based on the MAC information about a particular system, it will have a reference table of the swath width capability of that system. So as you lay down a track, it'll show you in a given depth what swath width we would expect. You can adjust the overlap you'd want to an existing line. And if you're doing a large polygon of a survey, again, adjusting overlaps, it'll lay out the survey for you automatically, give you the time it'll take to do it, the amount of overlap. And in our case, we also can look at the amount of new data. You can see here how we adjusted. We took the Great Circle route for Hawaii, adjusted it to maximize covering gaps. And we're using this now for planning our transit in the Northwest Passage. As we look to the future navigation, Tom Buckowitz and the Viz Lab are looking into the power of augmented reality to support navigation. They've been constrained in the past by limited daylight visibility of existing augmented reality glasses, but have found a new unit, this thing called the Nreal. That's a small, lightweight device. It has very good daylight capability. And as you can see, it's very, very stylish. You can see Tom there wearing the latest version. I hope they come in a range of colors. The lab has been looking at the real-time display of LiDAR point clouds to allow location of scanned infrastructure, things like the bridge here. This is the Crescent City Bridge in New Orleans on a foggy day, and we can present that to the navigator in real time. And it's a real challenge to render hundreds of millions of points quickly while registering it with the real world. And so I give a lot of credit to where they've come, and I think we still have a way to go with this, but this really, I think, bodes well for the future of augmented navigation capabilities. The lab has also been working on bringing bathymetry, including bag files, flow and LiDAR LAS files directly into what's called the Unity 3D engine. And this is probably the most common 3D graphics engine around. And this opens up the opportunity for displaying this kind of information on a number of platforms. Here we have a 6-mile section of the Mississippi River shoreline around New Orleans, again, containing hundreds of millions of points. And you're seeing just it projected onto a water surface as soon as we get the bathymetry. I think Tom is waiting for the full bathymetry from NOAA. That will be masked in, and you'll see the shoreline and the bathymetry connected. Last year, we showed our ability to recreate VR and AR scenes from Structure from Ocean, and this is something you really need to see and come to the lab with the goggles on. And our ability to annotate in the 3D scene. This year, that has been extended so that the annotation can be done directly on the 3D model just once, and then automatically propagated back. You can see all the calculations here to all of the thousands of video frames that can then be re-rendered from any point of view, showing the annotations. And this allows machine learning algorithms to learn how each object would appear from many, many different angles. And it really promotes robust machine learning identification. So we're quite excited about this capability. In our data management framework, Paul Johnson continues to provide a number of really helpful and useful map services. I encourage you to go to our web site and the map portal. You'll see a number of these map services, including databases for our ECS data, the Western Gulf of Mexico, the Gulf of Maine, the New England, Northeast US, and many, many more. And this has been done in collaboration with both Glenn and Katrina and the National Bathymetric Source. Paul has also built a really nice, useful tool for annotating problems in bathymetric data sets. We've been using this as CBED 2030 and JEPCO data come in, where you can just annotate up an issue and it goes into a common framework that people can look and see what the problem is. And finally, Paul has built this beautiful interactive web viewer for exploring JEPCO data. So again, you'll find those all at our web portal. We have also, for several years now, been trying to really understand the radiation patterns of multi-beam sonars that we use. Our colleague Xavier Lerton has done a wonderful job in trying to model those, but it's really hard to measure what the true radiation pattern of a deep water multi-beam is. And we've been very fortunate to be able to bring several times an EM-122 to the Navy's hydrophone array off San Clemente Island, where there are about 90 hydrophones on the seafloor. Mike Smith has been hard at work trying to unravel these very, very complex data sets, and he's made great progress and can now measure and visualize metrics like peak sound pressure and power spectral density through the different modes of operation of the sonar. And he has put together some really nice visualization tools. Let me see if I get these all started. They're all supposed to be in sync, but I couldn't get them to start at the same time. That we can look at these complex relationships of spatial and temporal variability of the received signals as the multi-beam sonar moves through the array. And so this is going to be great help to us as we try to start understanding what's going on there. Now, in parallel with that effort, we have also been looking at, and this is Hillary Cates Varkesi and Jen Mixer-Soles, the impact of the multi-beam on a resident population of Cuvée beaked whales at the range. We reported on that previously, Hillary's analysis of the temporal behavior of the whales and the paper she recently published, concluding that the multi-beam sonar did not appear to have an impact on the foraging behavior of the whales. She's now turned to the spatial behavior, aside from the temporal behavior, to look at how the whales have behaved spatially throughout the survey and the interaction with the multi-beam. And they've developed a global local comparison method to analyze that behavior. A paper on that method has already been published, and one using the results of the analysis, which again appear to show no change in foraging behavior that's related to the multi-beam, is currently under review. So we're very excited to get these clearly, carefully made measurements out to the public, and again, indicating no apparent effect on foraging behavior. Finally, we understand that at the end of the day, we serve the public and we have an obligation to inform the public about our activities and as best we can to engage the public with them where possible. And so we maintain a number of outreach efforts. Normally we, in a normal year, bring thousands of students and other visitors to our lab. Of course, COVID has presented that, so we've had to focus more on our web-based and social media efforts, which we've tried to do as best we can, and they've been well followed. We're very happy about that. Within the constraints of COVID, we've done what we can. We've had virtual sea perch interactions. And we're slowly now bringing school children in, hopefully marking the beginning to this end of, to quote Queen Elizabeth, she was speaking about other things, this Anno Horribilis. And hopefully we'll start bringing our own people in. And hopefully things will begin to return to normal. And even more, hopefully, we'll be able to bring you all back and visit us next year and do this properly and for real. And so with that, let me stop. I have no idea how long I ran over. Brian, you can yell at me now and tell me how long I ran over. But tell me where we are in terms of time, because I've just been going and paying no attention. Brian, where are we?
23, Larry. So you're a little over, but not by much.
Okay, well, that's a good start, I guess. Were we at our break time now? Is that? I can go try to find that.
I believe that was the case.
Yeah, I think we I don't want to have to go back through all those slides, but I'll stop sharing the slides actually, and see where we were scheduled for the break. I think it was. Am I the only one with the agenda?
I think we have a couple minutes to break. We have a couple minutes to spare if you wanted to.
Oh, that's amazing. I had a feeling I might have rushed too much.
Quick question: how long until Val has to come on? I might have to go fetch him.
Well, we have till the hour, actually. This whole session goes till the hour. So we have, the break was supposed to be at 14:50. So I'm actually 10 minutes ahead, I think. Is that true? I can go back and do it again more slowly.
Well, if you'd like, you could take some questions if there
Yeah,
are any at this
let's
point.
do that. That would be great. I cherish the idea of being able to take questions. So let me put something on so I can start seeing people. I've not at all followed the chat.
We haven't had any direct questions in the chat
Okay.
just yet, Barry, but if everybody wants to put anything in the chat, do so. Or if you raise your hand, you can also do that.
Raise your hand or
Or
just start yelling even if you want.
you can give that a try. We'll see how that goes.
Let me grab a drink too. It's just tea. Or, the other thing I can ask, if any one of our staff or faculty, if I said something wrong, which I probably did, if you want to correct something, if I misrepresented something that you're doing, if you want to jump in and say something about that. Val, we got time if you want to keep at it. We won't start till the top of the hour. Okay, so Mimi's asking about the formal undergrad internships between OE and NOAA ships. Well, to be honest, and I don't know if Tom is with us, Tom Weber, because he was the intermediary here. This was not as formal as we hoped it could have been, and maybe Andy will want to chime in too.
I think Mimi's asking about some OE interns rather than our OER interns rather than our ocean exploration. Maybe could you clarify that, Mimi?
Yeah, sorry, that was confusing. I do mean the ocean engineering, the two that went on the NOAA ships, the TJ, and I can't remember the other one. I think that's great. I'm just interested in learning more how it came about and what the arrangements were.
Yeah, so I don't know if Tom is with us because he's the one who made the arrangements. It was pretty ad hoc, I think. Andy, where's Andy? I know Andy is here. So Andy, can you chime in? I think just a general call went out and saying, could anybody take a couple of interns? You guys weren't out to sea yet, I don't think at all, Mimi.
Well, yeah, so I think, this is one of the things that Rick had been pushing us to do for a number of years to get people out. And I think that was the original impetus. And then we got some great support from the Fairweather and TJ and just did it. So, and by the way, Natalie Cook has been doing a blog, which is going to be featured on the Coast Survey blog as well as ours. So you can hear straight from her about her experience there. Something we'd like to continue for sure.
Yeah, we would. Yeah, but I think we'd like to. This was like, again, pretty ad hoc and last minute, and I think we'd like to see it more formalized in some way.
Okay, cool. Thanks. We're for OER, we still have our standard annual application period for our EAT program. So I was just wondering how formal it had become and if we could learn anything from what you guys have done. That's all. Thanks.
I think your program is much more formal and probably mature at this point. We probably want to learn some from you.
Right, and I know I can guarantee that when students started asking about internships, we referred them to OE and to OET, and neither were taking interns, I think, at that time because of the COVID situation. But that's always the first, the knee-jerk response when people are interested in internships, those formal programs. And so we kind of did this ad hoc with the TJ and the Fairweather.
And how long are they out for, the students?
That's a good question there, Mimi. So I think our original plan was they were going to be out for something like 6 weeks. Kind of with the port call somewhere in between. There was, with the case of Tom Spiro, there was an unexpected to us, what do you call it, R&R type? So, because there were all the COVID protocols. They had a quarantine before getting on. be in the bubble. And then what we didn't know is that in Alaska, the ship was going to have a 2-week period in port where everybody had to move off the ship. And to be honest, that became unbelievably expensive. We cannot afford to keep that student in a hotel for all that time. We somehow didn't qualify for the NOAA contract. So it was going to cost us a fortune. And so we brought him home we sent him to Thunder Bay to work on the project there. So that was just a communication mix up. Or it might've been that they didn't know that we're going to have that break in there, but he was supposed to be out for 6 weeks with the kind of a small port call. And I think that is what's happening with the person on the TJ. I think that's
Yeah, Bree put in 45 days, one closed bubble into the chat.
yeah. Mhm.
Yeah,
Okay.
maybe Bree wants to, maybe Bree would like to comment.
That would be great if Bree would chime in.
Mimi, it's very informal. They sent us candidates. We said they all looked great. And then they sent us one. And so far it's been really easy. We just took them as a scientist and treated them as a scientist. And we have been cycling her through all of the different departments, and she's got a little mini survey. But it's been really fun for us and quite simple. And I would advocate leaving it simple and maybe not as formal. But that's my opinion, though.
Fantastic. Yeah, it seems like they're with you guys for longer than we usually have them for. So yeah, I'll check in with you guys later and see like your takeaways.
And I guess what from our perspective, I mean, I have no qualms leaving it informal. I would like to have it formal enough so that they do somehow get some of the protection that the NOAA folks that if we have a situation where they're dumped off in port, they would be considered part of the NOAA team if they have to check into a hotel or something like that. I mean, we could still pay the money, but I think in the case with Tom, he was really just not by any. It was strictly the system, not the people. The people are doing everything they can. The XO and the skipper were trying every way they could to get him included, but they just couldn't get it done. I think if we formalized it enough that they would have some sort of official status on board that associated them with the program, that would probably help us. Andy, what do you think about that?
Well, Bree and I can work on that.
Yeah, we could probably hire them as ASTs or summer interns. We can actually hire them through NOAA, but it might defeat the point. But
yeah, Mimi, I don't know how that works with your interns, whether that is the case. I suspect it is somehow. That they
our interns come through UCAR actually. So OER's method of hiring temporary people in certain circumstances is to hire them through money that's already been given to UCAR. I don't know if Rachel's on the line right now. She can enunciate this better than I can or whatever, but yeah, so they are covered under like kind of like the blanket security of whatever UCAR would need to do to get people off the ship in an emergency or yeah, hotels, other things.
So
Yeah,
Genevieve has.
Oh, go ahead.
Oh,
Sorry.
Genevieve, bonjour.
Bonjour. It's great to see everyone. And as usual, I look forward to this review every year. Always get lots of ideas, and I'm just sad that we didn't have more time, to go through the projects, because what a great suite, what comprehensive, overview of all the different things going on. So I have a couple of very specific.
Genevieve, excuse me, but we're having real difficulty hearing you.
Okay. Okay, I'm not quite sure. How about, is that better? No, it isn't, is it? Okay,
If you speak right to your microphone, that will help there.
Or do what I did last night. Bye.
Is that any better?
Yes.
Yes, much better. Yeah.
Is that
So first, congratulations
as usual, I really look forward to hearing what's going on. I had a couple of very pointed questions. The first is about the augmented reality work that I know you've been, working on for a number of years. Wondering if there was any plan to test it out on one of the ships or one of the sea missions, just to see how it works when you're actually on board a ship. Or even if you've already done that. That was my first question. My second is for Brianna and the S-131. Wondering from a science and engineering perspective, what are some of the key questions that need to be answered? Because from a hydrographic office perspective, we've been trying to engage our ports, and we're looking from an operational perspective at engaging folks. But I'd like to understand from the back end, what are some of the key science or engineering questions that need answered before we can consider operationalizing it. So thank you.
Okay, so let me turn to Tom Butkowitz to respond to the augmented reality. I think we have a good idea where he's going with that, but go ahead, Tom.
Yeah, so we're developing it where the headset is really just a viewer, and then a separate application gives it what to display and what coordinates it's at. So that should allow us to use it out on a boat or in the lab using a simulator. And we'll probably test it out first on the RV Gulf Surveyor and something like that. But then ultimately, yeah, we could take it out on a ship, or those headsets are really only about $600. So we could kind of distribute headsets to people to test out on their own.
And I think this will also may go hand in hand, and I'll let Andy and Christos comment about that with our hopefully, and Christos will talk more about it, closer associations with some of the maritime academies who I think have very, very sophisticated simulators available. And I think we would like to offer this as a kind of a low cost approach, not from a simulator perspective, but adding that augmented reality approach. And I'm looking at the participant list, and I don't see Brianna Sullivan. Is Brianna Sullivan here? I don't see her on the list. So I apologize about that, but we will pass on the question to her and make sure she gets back to you. Rachel.
Hello. Tom, I actually just had a question for you. It struck me about the augmented reality. Are you also creating training data sets that you intend to potentially give out to different maritime academies so that everybody's sort of looking at a standardized system and then building out AI and machine learning from that? Or is that part of that, or is that just taking a step too far? Or maybe you don't understand what I'm asking.
I'm sorry, what kind of training? What would the AI be in terms of?
So
AI?
I guess one of the things we're kind of interested in is when we're doing our video, we've got our video annotations, our imagery, building out sort of standard and QA/QCing different annotations within those video sets. And I could see that application having a standard video training data set that everybody could look to that has full sort of features and creatures identification on it, and then being able to apply AI or machine learning code to something that's standardized that way. Whatever your application might be, or whatever your interest might be. So it might be corals or something like that.
I was confused. That's actually a virtual reality one. And one of the limitations of that is, since we're doing the annotations in 3D on the structure from motion model that's generated from the video, the model that you see is not capturing everything that's in the video frames. So if there's fish that are swimming by the camera, or if there's seaweeds that are kind of wiggling about, those usually will not show up in the structure from motion model. So you won't have 100% of every still image video frame annotated, because some things don't make it into that 3D model. But certainly, if someone wanted to go through and clean those up and kind of fill in those gaps, they could do that as well.
Okay.
Great, thank you.
Thank you, Tom, and thank you, Rachel. We should probably take our break now. Let's make it about 7-8 minutes. Let's come back 5 after the hour to give you a full 10-minute break. And if Val is, I'll call Val. I see Roland's there. We'll get Val ready. We're going to try to do this live from the warehouse. So there's Val. So Val, you think you'll be ready 10 minutes? Is that okay? Okay, sounds good. All right, thank you, everybody. We'll see you back here at 5 minutes after the hour.
Hey, Liz, I don't know if you're still on the line, but do you want to give that other microphone you have a test?
Yes, I'm here. How do I sound?
It sounds good.
Excellent. All right,
Yeah,
I
yeah.
will keep with these then.
All right then, cool.
Cool. Thanks,
Well,
Will.
that was easy.
Yep.
Well, I thought you were going to have the hat cam. The camera on the hat.
It'd be a great idea. We did get nice hats.
Yeah, I saw that. Yeah. $6,000 hat.
Pay all that money for the boat, we get some hats. Is that the plan?
No, that's taking the course.
Okay.
Not a bottle of wine in the box, though.
Don't talk about wine on university ground.
Are you wearing the new shirt, Val?
I don't tell. I'm not. I wore the new shirt on the first day of the training, and then I had to wear the old shirt. So I did a lot of crawling around on the first day.
Okay, who's got the official clock?
Bong.
5 after?
The time according to Apple time servers is 6 minutes past 3.
Oh, that's 1 minute too late. Okay, let's start up again then. And as I said, we're going to have just 3 presentations that go a little more in depth into into some of the topics that I presented. And we're going to start with our USV efforts that are led by Val Schmidt. Val is not on site, so to speak, with us. As I mentioned, the OECI DRIX just arrived a few days ago, and he's been busy unpacking it and setting it up. And he'll, I think, give us a little tour around, take a look at that, but then also talk more formally about some of our JHC ASV efforts. Val, go ahead, please.
All right. Hello, everyone. It's great to be with you virtually, if nothing else. I'm going to take you for a little ride around the space here. I apologize. There's a lot going on here, and it might be a little loud at times. And if it becomes too difficult to understand me, maybe Larry, let me know, and I'll find a more quiet place for everything else.
Right now, it's perfect. So
great. So we're in a facility called the Olson Center for Advanced Manufacturing here on campus. And a big part of the facility is that direction, which you can't see, but it's all kinds of robotic arms and fancy machines for additive and subtractive manufacturing. And we've carved out a space in this facility to house sort of a second workspace for autonomous surface vehicles or unmanned surface vehicle work. And so that's where we have the DRIX. So as Larry said, the DRIX was funded by NOAA OECI grant, and it just arrived to us, and much of it is very new. It's DRIX Hall 8, the 8th one that they've made. DRIX Hall 9 is in the works, and maybe 10 as well, actually. Let's see, let me back up so you can see. So it's within a docking system. It's called the Universal Docking System, these narrow halls, and then the DRIX itself is the red bit that's in there and the mast up over the top. And you can get a sense here if I move this out of the way. Very narrow hull, wave-piercing bow, not very wide at all, and some 25 feet long, so a little bit over 8 meters, 7.7 meters long, I guess, altogether. So very fast and very efficient. And then the business end, from our perspective, is this gondola here on the bottom. It's not extended to its full extent here in the lab, but that houses the EM2040 and for us 2 EK 80 transducers, and then alternately a USBL transducer will go in there as well. So we're super excited about this. The Universal Docking System is the first time this has ever been built in its current incantation. It can either be lifted fore and aft from 2 different points for a davit kind of lift, or there's a docking head interface module that's sitting over here that lands up on top, and you can do a single point lift from a crane. So yeah. So right now the training that's going on is the electrical system training. So they've got the schematics out, and I've been arguing with Italian and French guys. The trainer is Italian and everybody else is French, so I might break into a funny accent. here before long, but yeah, so you've got to put that someplace else. Sorry, KG brought out the big fan because it's gotten kind of stuffy in here, but I don't want to compete with that. Oh, let me show you maybe a few other things. So there's parts that would go on the mothership here, and part of the user interface there, kind of give you a sense of how all that will work, and lots of kit, remote controls and supplies and spares and all of that kind of stuff. And then to go slowly here, Roland is working on putting our own backseat driver system onto a computer that will go into the boat, which will allow us to take all the work that we've been doing for the last 5 years and just insert it directly into that. And the really neat thing about this is that the DRIX internal middleware is built on the robotic operating system, which if you know me, you've heard me talk about that a lot, but it's the same middleware that we use in the lab. It's an open source thing. So it's almost trivial for us to take our kit and stick it in there and be able to talk to the boat, which is really exciting because we've been working on lots of things, and a lot of those will be able to port into here easily and share with our corporate partners who also have ROS-based systems. So I think that's it for the tour for now. And I'm going to jump into some slides and talk about some of the things that we've been working on this past year. Most of it not related to DRIX. So bear with me for a minute while I share my screen. Oh, host is disabled participant screen sharing for me. Can I have an assist, please?
Yeah, we're on it.
Coming up now.
Yeah.
Thank you. Terrific. Okay, did that work okay?
Looks good, Val. Carry on.
Good.
Thank you. Okay. Back in November, well, it was published in November, but actually we wrote it before that. We wrote an ASV best practices guide for hydrographic survey. This was sort of a culmination of thinking and hard-won lessons learned about of the operations that we've done over the last 5 years or so. We got our first ASV, Ben, in 2016. So, so this was a lot of experience and time on ships, the Fairweather, the Thomas Jefferson, the Okeanos Explorer. Sorry, not the Okeanos Explorer. I wish the Okeanos Explorer. The Nautilus, and then multiple operations from shore. There's all kinds of good stuff in here. I think some things that are probably worthy of argument, but that's okay. Things like using a risk management guide when you go out. Following cold regs is obvious, but following the spirit of cold regs to maintain things safe when you can't meet all of those requirements as they're written, not impeding the passage of other vessels. Maybe the biggest takeaway is making sure that the operators and the ship operators are working on the same virtual page, meaning that they have the same displays in both places. Turns out that when they don't, and they're trying to communicate complex navigation situations or technical information back and forth, it can be really difficult. I won't belabor that, but if anybody has anything that reads that and has feedback, I would really appreciate it. Your comments are totally welcome. The rest of our year was really spent working up for an expedition to Thunder Bay National Marine Sanctuary, and I'm going to use that trip to sort of frame all of our work. This was out of Rogers City, Michigan, which, if you think of the left-hand mitten that is the state of Michigan, it's kind of where the upper part of your index finger is. And this was in collaboration, of course, with NOAA's Thunder Bay National Marine Sanctuary itself, and the Ocean Exploration Trust. We carted our kit out there in the trailer you see here to the left, and that was also our mobile command station. So we were doing most of our operations from shore. And if you haven't seen it before, our other ASV, Ben, the Bathymetric Explorer and Navigator, is to the lower right there. It wasn't just us out there, though. We had 5 folks from other parts of NOAA. Lieutenant Mike Card is on the left there. He works with OMAO and their Undercommand Systems Group. Rob Downs on the right is from CSDL. and there were folks from NRTs as well out there helping us, standing under instruction watches and helping us with the mission. People always give me a really hard time about how many people it takes to operate an unmanned boat. So I thought this slide was fun, but I got to explain this. So Erin is on the far left there. She's actually processing data, so she's not operating an unmanned boat. Steve Wizzo is next to her. He's a PhD student. He's writing code for calculating CPA to other ships. Roland is next to him. He's our lead software developer. He's writing code to interface with our new radar system that is a dual range Halo model radar system that stabilizes that in our display. Clint next to him is a survey tech from NOAA, but also a grad student in our lab, and he's actually standing a watch. He's monitoring the sonar system and being our log taker. Next to him is Andy McLeod. Andy is an engineer working for me, and he is kind of the over-instruction ASV pilot. And next to him is Alex. Alex works on the NRT team at Stennis, and he's the pilot under instruction. So really, there's only two watch standards there. I am in the back, probably right in the middle of Larry, and my card is kind of watching over the top. So anyhow, we had a good team and lots of help when we needed it. This is kind of a view of what our operator station looks like. So each one of the blue squares you see there is like a physical monitor. And then some of these monitors you can carve up into multiple displays and feed them from different inputs. So we had 3 laptops. You can see their displays on the very bottom. And then some of those all of those laptops were also feeding some combination of these multiple external displays. And I'm going to kind of step through these to give you a sense of what we're doing and how we're managing all of that. So all of these displays were driven from one computer. And the first one I want to talk about is this one over here on the right. This is CAMP, the CCOM Autonomous Mission Planner. This is our own software that Roland has largely written. Well, he has written all of it. In this you can see the kind of the chart display and the background data we've collected before. You can see Ben down there at the lower part of the display, and he's on a track line out to our survey area. He's about 5 kilometers from us right now on his way out there, and our survey areas, these survey lines in the inscribed polygon that were planned. You can also see an AIS contact in the upper left that gets displayed there. So that AIS contact may have been detected by Ben's AIS receiver, but we also have an AIS receiver on our control van, so it could have come from there. It would get displayed here. And we also put an AIS receiver on the Sanctuary's launch, the NOAA ship 3011, and a radio on it. And so if that boat detected another vessel via AIS, it would also show up on our display, kind of fusing data from all of those different places. And maybe you can tell the CPA to that contact is going to be really close, right at the beginning of our survey area. So we've designed this alternate survey path here so that we can hang a left turn. We'll be about a nautical mile away from this big freighter that's coming through, and as soon as he passes, then we'll go back over to the survey area. Okay, so the next display I want to talk about is the one to the upper left, and it's the same software, another instance of CAMP actually running on the same computer, such as the wizardry of Roland's work. But this one, we zoom out and we take a broader view. We have a different background, in this case, the raster nautical chart. You can see Ben's in the same place, and you can see there's other AIS contacts on this map that you didn't see on the other one because we've taken a look further afield. You can see some green overlay from our radar there, and the other radar, the short range one, we usually display in magenta, and there's nothing near Ben, so you don't see any of its input. One quirky thing about this raster chart, for those of you who are hydrographers and cartographers, if I back up to the ENC, you'll see these dotted lines that indicate the preferred routes for commercial shipping. You'll notice those are missing off the raster chart. I don't know why that is, but it's a quirk to me, and it would have been useful to us had they still been there. Okay, moving on. Sometimes we want to look even further afield for big freighters, because there's a lot of them in the Great Lakes. And so we bring up marinevesseltraffic.com. You can see all the same contacts, and you can see Ben there right by Rogers City. That pink icon is Ben's AIS. And you can see there's some other ships further afield. We do this because those ships go so much faster than Ben does. Ben only goes like 5 knots, but those other ships go quite fast. And we like to have some time some warning when they're coming to think about what to do that's both safe and efficient for our mapping plans. And then this display in the middle, this is one that kind of comes for free with the robotic operating system. We can pick different data streams that are being published on our operator station. Some of those come from the boat, some of them are generated locally, and then we can plot them in real time. And so the top one is Wi-Fi throughput on the left and signal to noise ratio. And the middle one is from the Kongsberg Marine broadband radio, which you kind of think of as super Wi-Fi, goes much further than Wi-Fi does. It's a licensed radio, and it's SNR on the right, and then the vessel speed there. We monitor the signal to noise of our radios all the time because it's a huge indicator of when we're likely to lose connectivity to the boat, and it has some major impacts on how we operate. By way of an example, on a good telemetry day, when the conditions are good with the Kongsberg Marine broadband radio, of course, this is antenna height dependent on both sides, but we can operate easily out to 20 kilometers. And that's over the sort of visual line of sight. But if the conditions are not great, on a humid day where there's fog or rain, it could be less than 10 kilometers. And of course, there's a huge difference in the area that you can survey with those. So we would look for fair weather days or at least good telemetry days. Not all fair weather days are good telemetry days, and use those to survey the outer parts. But this got us thinking about other ways that we could operate. And so for the first time, what we did through some actually great forethought on Roland's part, he had envisioned this scenario long before the rest of us did. We installed a radio system on Noah's small boat that was helping support us, and a laptop computer and yet another instance of camp. And we transferred control from our operator station to that launch. So as Ben approached the limit of telemetry on a given day, if we wanted to operate outside that limit of telemetry, in fact, there were some areas that we wanted to survey that were in excess of 30 kilometers away, way beyond what we would ever be able to do from shore, but we could transfer control to the 3011, and the 3011 could escort Ben out to that area, maybe do CTD casts for it as well, but do all the mission planning on board the small boat. And then as the boat came home, we transferred control back to the operator station on shore. So this, of course, got us thinking and about a different operational model than we had thought of before. And since you guys are thinking about these things for new ships, I thought I would lay out sort of a scenario just for fun. So imagine that you have a ship that has a couple of normal crewed launches and a couple of uncrewed surface vessels on the stern and an operator station on board. And maybe you deploy a couple of those uncrewed systems, and then you park them and keep them in one place. And maybe while they're parked there, survey tech is making sure their sonars are all configured properly and the nav systems are working correctly. And in the meantime, you launch a manned vessel. And then you transfer control of those two unmanned systems to the manned survey launch, and they are tasked with a set of survey lines to run someplace far afield, and off they go. And authority or responsibility for the unmanned systems is turned over from the big ship to the little one. And then you deploy the other two unmanned systems, you park those, do the same kind of thing, deploy the manned system, retask or reassign the operational control of those to the manned launch, and off they go for their surveys. So in this way, you can totally operate the unmanned systems independent of the mothership, outside of its telemetry range natively, and divvy up kind of the operational responsibility, the cognitive loading of managing 4 different vessels at once, split up the responsibility among watchstanders who are sort of geographically dispersed. And that seems like a really powerful model and a really nice way to do things, rather than operate all of the vessels from one central place. And you could imagine the case where one of the unmanned systems has some hiccup that needs human attention. You could send it back to the mothership. The mothership would take control when it's in its telemetry range, bring it on board, fix it, whatever it is, plug the wire back in or whatever, put it back in the water, and off it goes back to finish the day's work. So that seems like a neat model to us, a really powerful one that we're going to continue to drive functionality into our own software, but also talk with our corporate partners about how their software systems might be able to facilitate that kind of thing. Our initial inquiries, I don't think any of them really do support that kind of a model yet, but so it'll be a fun thing to tackle. It's gotten kind of loud here. I hope it's still going okay and you guys can hear me okay. I apologize for it.
It's just fine, Val. No problem.
Okay. Thank you. There's been lots of other stuff going on in this off season. A whole bunch of things in our software framework for marine robotics, which we call Project 11. Some of it dealing with cameras, other bits and pieces of software related to hardware. A huge number of features that went into new features that went into the CCOM Autonomous Mission Planner. We're building our own CTD winch system, installing it on Ben, and what you see in the picture is a dummy CTD that matches the size and weight so we can test it. And in the bottom right, we're testing something called Parallel Redundancy Protocol. It's just kind of a new protocol. It's a networking protocol. It's meant for industrial settings for really high reliability communication with zero failover time between systems over different kinds of links. And we think it might work really well for unmanned systems, but the proof is in the pudding yet. And we'll talk more about that when we have some real results to report. Okay, so what's next? So we have a busy dance card this July for sure. We're a couple of days into the 2 weeks of DRIX training, which the first half will be here in the lab, and then the latter half will be down at the pier and out on the water. After that, we're going to do some sort of formal acceptance trials with the DRIX, just part of the acceptance of the purchase of it, and then a bunch of sonar testing for the systems on board to make sure that those are operating properly. And if we have time, I hope, we'll make time, some preliminary calibrations and sort of sorting out how to best do calibrations of the fisheries systems, EK systems on a vehicle like this. So that's going to take us through July. I don't have a slide for August because I am taken off. But in September, we're shipping all of this stuff in August to California, and in September, we're gonna go through the process of integrating this kit on the Nautilus as a first go, and training the crew and doing drills and understanding how to operate an autonomous surface vessel from that ship and teaching them how to do it safely from sea. All of that is to work up for a collaborative project that's, of course, funded through the OECI, which is with Woods Hole and the Mesobot and another ASB that I forgot to mention, actually, the NUI. But it's sort of a tech challenge to integrate the DRIX's ability to position things with its USBL and communicate with acoustic modems with that underwater vehicle as a first step to building a more formal technical relationship both with that team and between the systems. So so we've been super busy. The work that is funded by, all of this stuff, I think Larry said I get confused, I have to admit, but and I'm gonna get in trouble if I get this wrong, but it's funded by the Coast Survey grant, and the OECI stuff and this blend really nicely because we're building on top of the strengths of both of those programs, and the support is terrific. So that's all I have, and I'm more than happy to answer anyone's questions.
Well, thanks so much, Val. And I know we're taking out of your precious training time here. Maybe to avoid Val having to come back at 4, we'll see if there are any questions. Mike Jeck had a question about why we didn't take the DRIX out to the Great Lakes, and I think I offered him a series of reasons, mostly just not ready, not quite ready for that yet. But if there's any other question right now, maybe we can entertain that and save you from having to come back. So I take a look. If you stop sharing your screen, I get a better view of people raising their hand.
Oh yeah, sure. Sorry.
And I don't see any more in in the chat. So I learned I'm supposed to count to 7. But I'm very impatient. Whoop, here's some. Lorraine has some questions. She'll follow up with you later. That's best. And I appreciate that, Lorraine, because we're actually paying for Val's training time right now. Okay. Oh, that's actually, that's good. She wants to talk about the discrepancy on the chart. And that's great because I was very curious about that too. So we're very keen to learn about that.
So Val, do you have any NOAA folks there in your training session right now?
We do, and I apologize. Thank you for the prompt. Yeah, we have Chloe, who's a survey tech off the TJ, and Harper Umphris and Taylor. I can't say his last name, Crable, but they're both from Coast Survey Development Lab, and they're all going through the training as well with all of this stuff. So they're right now up to their elbows in the electrical system, and they've been in the thick of it with us through all of this, which has been, it's been really great. Yeah, super helpful folks too.
Okay, that's great. Thanks, Val. You go back to it. I'll check up tomorrow on you. See.
All right.
See how
Take
you're
care,
doing.
everybody.
Thank you
Thanks
so
a lot.
much. All right,
Bye.
now we're going to turn to Liz Widener. And as I mentioned earlier, Liz is one of our, she started with us as a master's student, and she was just so good, we couldn't let her go. So we convinced her to go on for a PhD. And she is deep into her PhD now, which is looking at a number of different issues in the water column. But she also will take on the responsibility of teaching this new undergraduate course. And I think we and she are all excited about that. So let me just turn it over to Liz, who'll talk about some about the water column work she and Tom and Alex are doing, and then also about the new course. Let's go to it. And Liz, I don't know if they'll have to allow you permission to share your screen, but somebody.
I think I'm good. I think I should be
You're okay?
good.
Yep,
It's,
good.
I am sharing it. You guys good? You can see my screen. You can
Yep,
hear me?
excellent. Excellent. Thank you.
All right. So, thank you, Larry. As Larry said, my name is Elizabeth Widener. I'm a PhD candidate in oceanography at the center. And today I'm just going to be talking about some of the acoustic water column research that's happening here at CCOM. I'm going to be talking a bit about a new acoustic scattering model for ocean structure and a little bit of work on an automated method for gas seep flux quantification. And then, as Larry said, I will be reviewing a new undergraduate course in ocean mapping that I'm going to be offering this fall. I'm very excited, a little bit nervous about that. So let's get started. If I can get my slide to turn, there we go. So I'm going to start by talking about acoustically studying water column structure. And Larry touched upon this when he was running through all the different topics earlier today, talking about the very real impact that the structure of the water column has on bathymetric data, especially for the near surface structure. Anybody who's been part of a near shore survey operation knows the water column structure can change very rapidly, and it's not always feasible to be continuously taking CTD or XBT casts. So the idea that we could potentially characterize the water column with an acoustic system is of particular interest to us, both for direct mapping applications, but also to understand the ocean as a whole. So to this end, several of us at CCOM, you can see me, Tom Weber, Larry there, as well as colleagues from Stockholm University in Sweden, have been reporting that broadband acoustic systems really are able to observe temperature and salinity structure in the water column. And you can see some examples here from some of our publications over the last few years. Here in the Arctic Ocean, we've observed the depth of the mixed layer, this region of enhanced scattering at about 25 meters, and we tracked that for over 100 kilometers. A lot of high and low frequency variability there. Also in the Arctic, individual thermohaline staircases. So for each of these very minute changes in temperature and salinity, we see a corresponding very thin acoustic scattering interface. And then in the Baltic, you'll see this very strong stratification interface that's actually associated with the halocline, a salinity-driven structure. It also denotes the onset of anoxia, which is a lack of oxygen in the water column, a dead zone. Dead zones found not only in the Baltic Sea, but here in the States, Chesapeake Bay, Puget Sound, both having seasonal issues with anoxia. So as a result of these publications and our sort of realization that broadband acoustics can observe, in some cases, very small changes in water column structure, we started to explore the sort of theoretical underpinnings, the physics of the acoustics that allows us to make these observations. So in an effort to really explain what we are seeing in a more quantifiable way to move from observing these structures to actually extracting information. So the result is a new acoustic scattering model from scattering from water column stratification structure that really helps us describe our ability to observe smooth layers in the water column, because there are no step changes, no discontinuities. What we have are these gradients. You know, there are regions of transition between water masses that define stratification structure, and they're made up of smooth gradients with characteristic length scales. So this expression at the top of the slide is the acoustic model for the scatter pressure that what we would observe from this kind of structure. So diving into this model just a bit, scattering is driven by two different forcing terms, the sound speed or the wave number term, and a more complex density gradient term. And so we evaluated the importance of these terms for real ocean stratification interfaces like those that I introduced a bit earlier, and that we found that this density gradient term is nearly always negligible for ocean conditions. The scattering is just totally dominated by the sound speed change. The only exception is locations where you have fresh and salt water interacting, such as glacial meltwater lenses at low frequencies. So by removing this term, and also simplifying for the backscattering case, so that's the geometry where the transducer and the receiver are in the same location. So that's the case for our ocean mapping vessels with hull-mounted systems. We can simplify to the expression at the bottom of the slide. And this expression tells us that the scattering, P of S, the scattering from ocean stratification structure, environmentally is driven by sound speed perturbations, this delta K term here, which means that the scattering that we're observing in these cases is really driven by just changes in sound speed. And with a little bit more information, we might be able to invert this acoustic data to more quantitatively understand how sound speed is changing. So as an example, we have some results here, model predictions for ocean stratification structure. So we took our model and we defined this delta K term based on a sound speed profile from a CTD cast in the Arctic. So this is real, in situ data. And this water column has a really strong mixed layer boundary, which you can see up here. It also has a number of thermohaline staircases. So that's in this zoomed in box right here. And what we did, we ran the model with two different acoustic pulses, one at 2 kilohertz and one at 20. And our model predictions, first off, they suggest very strong frequency dependence to the scattering. So you can see here, reflections from our mixed layer boundary, the 2 kilohertz reflections are significantly stronger, almost an order of magnitude stronger than the 20 kilohertz reflection at the same boundary. The model also highlights how sensitive the acoustics are to changes in sound speed. If we look at the thermohaline staircase region, where you have at each step a very minor change in sound speed, in the 20 kilohertz data, we see very well separated individual reflection peaks for every individual staircase step. So under the right conditions, which are a combination of the environment, but also the acoustic, the insonification frequency, acoustics offers us the means to study the structure of the ocean and in really high resolution, higher maybe even than CTD casts. And we all know that acoustic profiles are much quicker to collect than CTD profiles. And so we've taken to calling this sort of potential tool the acoustic microstructure probe. You can thank Tom Weber for that name. And in the future, in the next few months, actually, we're going to work to expand this model to consider angular dependence of the backscattering response so that we can use acoustic water column data collected with multibeams with this model. You know, I know, and we can see in these images that ocean structure is observable in multibeam water column data. Larry had mentioned this several times earlier, and multi-beam water column data really provides us with additional information on the spatial extent of the stratification interface. And of course, we want to map once and use many times. We're already collecting this water column data with our bathymetric data sets. So wouldn't it be fantastic to be able to utilize this sort of additional facet of multi-beam data? So in order to consider the angular dependence, we're going to incorporate a interface roughness, surface roughness into our model. In October, we'll be on a research cruise on the RV Sevilla in the Kattegat, North Sea, where we'll be testing both our prediction of frequency dependence from our model, but also the feasibility of using a multi-beam water column data for this model for our acoustic microstructure probe. So stay tuned for updates on that. I'm going to Switch gears now, Larry mentioned I'd also be talking about developments in the study of natural gas seep features using acoustic water column data. So CCOM's worked for many years to sort of push the limits of quantitative midwater mapping, particularly working towards remote estimations of gas flux. And motivating this work is really that in survey operations on the continental shelf, sometimes even shallower coastal waters, we regularly identify gas seeps in water column data. However, there's a big separation, a chasm really, between acoustically seeing a seep and actually quantifying its gas flux. And that in part is what this effort headed up by Alex Padilla and Tom Weber aims to address. So as Larry said, the California State Land Commission has provided funding for the installation of an acoustic observatory on oil platform Holly off the coast of Santa Barbara, and you can see an image of that here. They use a 200 kilohertz split beam echo sounder installed right on the platform to look out through this seep field, and you can see in this echogram a seep feature basically sitting there in the view of the echo sounder. And the system's been running for over a year. We have here a year's worth of data broken into individual months. In the water column, we can see this strong scattering from the seep. It looks like it's vecting probably back and forth with currents or maybe tides. And with a long-term acoustic data set like this, one question that you might ask is, how is the gas flux or gas flow rate changing at this location? Because we can observe that there are some pretty dramatic changes throughout the year, but what we'd like are hard numbers, right, on gas flux. And so to answer that at this location, or really in any other acoustic data set of a gas seep, we have to link, what we acoustically observe to an estimate of gas flux rate, and that is no small task. So what Tom and Alex are doing are acoustically classifying different types of plume structures, or what they're calling plume geometry, because the geometry of the gas seep in the acoustic beam is very central to the calculation of gas flux, the actual equation that you use. And so here we have some examples of the different geometries they've identified. So we have, discrete columns of bubbles rising from the seafloor. Sometimes you get combinations of those columns to create a curtain of bubbles. So you can imagine long in one dimension, but short in another. And then sometimes there are bubble clouds, and that's where there's bubbles, throughout the water column extending beyond the acoustic beam. And they're using split aperture processing to calculate the along and athwartship angles of the acoustic data. And from that, they can determine the position and the coherence of different types of targets in the water column. And the reason that coherence really matters is because different plume geometries have different patterns of coherence. So for example, if you're thinking about that discrete column, there is coherence both along and across track. But if you're looking at a cloud, you won't see coherence in either direction. And so you have this ability to sort of acoustically disentangle your data and determine seep geometry. So with that kind of information, you can create this acoustic classification map. This is just 1 week in March, where the plume geometry has actually been pulled from the acoustic data alone. They don't have any in situ sampling here of this gas seep system. So for example, in this echogram, you can see that the cloud geometry in orange really makes up the majority of the scattering that we're observing. So by determining geometry, we now know how to apply the correct acoustic inversion equation, and we can work towards gas flux measurements. So using this table, and don't worry, I'm not going to go through the whole thing, but this table really tells us how we can automate our coherence classification based on our plume geometry in order to then compute gas flux or gas flow rate through acoustic inversion. And the long-term goal of this research is really to define this method for automated remote acoustic measurements of gas flux, and then of course to apply it at Coal Oil Point Seep Field, but then move beyond and utilize it in a number of other acoustic data sets collected at CCOM, but potentially beyond to better inform gas flux rates, throughout the ocean. So again, stay tuned for more results from this research. And then I have no idea what my time is, but with the last little bit of it, I'm going to just talk a bit about the new undergraduate course that's being offered in the fall. So Larry talked about this, I think, quite a bit, but there's been ongoing work to sort of grow the stronger connection, because there's a really great UNH undergraduate program, Bachelor of Science in Ocean Engineering, and we'd like to create more connections between that program, those students, and CCOM, as well as just the ocean mapping community in general. And so to this end, we've reworked John Hughes Clark's graduate class into a format that's more specifically aimed at undergraduates. We're not replacing the graduate class, it's just that we're trying to separate to sort of maximize the value because graduate students and undergraduate students have different needs. So I'll be teaching the course called it Introduction to Ocean Mapping, OE 774. I've left it open to advanced undergraduates, so juniors and seniors, anyone from the College of Engineering and Physical Sciences, which means that we could, in theory, get some earth science students as well as ocean engineering students. My goal is to provide the students with a relatively broad view of ocean mapping as a field, as well as some hands-on experience on the Gulf Surveyor. So as far as course topics go, we're really going to start with a brief history of ocean mapping because I want to give them context for how rapidly this field is changing, even within the last decade, but sort of take them through the evolution of echo sounders and I guess pre-sound as well. We'll also talk about the fundamentals of ocean mapping, so really building blocks, underwater acoustics, physical and geological oceanography, spatial reference frames. I'm not going to go very deep into any of these topics because there are existing excellent graduate level courses at UNH that cover this material in depth. I have taken all of them. So the idea is to just give them some basic tools that they need, and then they could take these courses in the future. We'll then cover ocean mapping systems, focusing mainly on multi-beams, but also touching on the combination of single beam side scan, survey, sub-bottom and seismic profilers, and then airborne LiDAR methods as well. A large portion of the class will discuss the integration of the many auxiliary data sets that we really need to make acoustic data into accurate and precise bathymetry. We'll spend some time in survey planning and discuss field procedures to go with sort of the hands-on work on the RV Gulf Surveyor. We'll collect some bathymetric data to facilitate our discussion of data processing, just the general multi-beam data processing pipeline, but also cleaning methods. And at the end of the semester, it's really exciting. We're going to have a bunch of experts come in from CCOM and maybe even beyond to talk about different applications and platforms for ocean mapping. So that'll be, exploration of the oceans. Hopefully Val will come in and talk about autonomous vehicles, nautical charting, habitat characterization, offshore oil and gas, green energy, to really give the students a sense of what the field of ocean mapping entails. And the goal of this course and of many of the efforts that Larry had covered, the internship, is to really provide a pathway for UNH undergrads into both graduate education at CCOM, of course, but also directly into NOAA and into the hydrographic industry in general. So that's everything I have. I'm hoping I didn't go over time. I'm happy to take questions, and thanks for your attention.
Well, thank you so much, Liz. Let's hold off questions until after Christos's presentation. But I think to all of you, I think you see from the clarity of Liz's presentation of the very complicated water column work, why we're so excited about her teaching the undergraduate course too. So we're really looking forward to that. And now finally, our last presentation, and we really have to give the Heroes Medal to Christos, who's sitting in Greece right now. And so it's, I don't know how late or early in the morning for him, but he's been drinking coffee all day to stay awake. And he'll talk to us about some of the cartographic directions we're taking. Christos, please.
And just started the Scotch for now. It's almost 11 p.m. now here. So yeah, let me share my screen. You all see my screen?
Yes, but just the background right now. Yep, that's it now.
There it is.
Okay.
It's there.
Great. So thank you, Larry. As Larry said, today I'm going to present our cartographic activities, or better, the cartographic activities that I have been involved in the past 12 months. But what he did not say is that due to the limited time and the number of projects, as you see here on the slide, I'm going to be talking fast, certainly faster than Larry earlier. Sounding selection validation is one of the first projects I started working on here at CCOM, along with 3 others, which I'm not going to present today: the statistical characterization of depth curves, the vertical continuity on charts, and the nautical surface reconstruction. The scope of this project is to validate the SOAL biased character of charted depths in an automated manner. In the previous reporting periods, we described what cartographers do manually to perform the task, and implemented modified enhanced versions of the IHO triangle and edge tests to best replicate this practice. We also identified and documented the intrinsic, as we call it, limitation of the two tests that prevents the implementation of a fully automated solution based solely on them. To address this issue, we developed the surface test to capture the relevant discrepancies at the appropriate resolution for the scale of the product. Accordingly, we developed a set of tools working with ArcGIS, the native MCD production environment. In this reporting period, we continued the efforts to make the three tools operational with MCD. New users were added and improvements to the tools were made based on their feedback. This includes the development of a detailed documentation, about 60 pages long, bug fixing, new visualizations of outputs, flexibility of the coordinate systems, flexibility and validation of input layers, and others. In the next reporting period, we will continue the research to operations effort. Next project is the hydrographic sounding selection. The scope is to generalize high-resolution bathymetry to a reduced density soil bias dataset that will facilitate the subsequent cartographic sounding selection. Currently, the high-resolution survey dataset is generalized to a more manageable dataset using radius or grid-based approaches. However, the output of these automated algorithms are extremely dense for the purpose, something that increases the burden and cost of the subsequent mostly manual cartographic sounding selection. Also, the radius and grid-based algorithms are highly dependent on the user input parameters. Different radius or grid size results in different selections. Different point of origin results also in different selection. As a result, the final selection from this process is often not the optimal, something that the sounding selection validation project that we discussed previously has shown. We propose a new soil-biased label-based generalization method that is product-driven and independent of user input parameters. Specifically, the only input is the scale of the product, which is used along with the ECDIS rendering rules and human perception factors to calculate the depth label footprints on ECDIS screens that are used to perform the soil bias selection, and the legibility rectangles, as we call them, that are used to account for neighbors' footprints. The output is a reduced density dataset, which you can picture of as a digital smooth sheet, that can facilitate the subsequent cartographic sounding selection. Most importantly, the testing has shown that our algorithm performs best in regards to safety and legibility in comparison to radius and grid-based approaches. We are working on making the tools operational with MCD. Before moving on to the next projects, there is, of course, and there will be need for traditional products, but there is also the global interest in precision nav products. Although I'm not going to present something specifically on the precision nav today, this is something we are also pursuing, and parts of the works that I'm going to present, including this one, can be incorporated in this effort. For instance, the label-based generalization algorithm is certainly relevant, as it can be used without parameterization to derive high-definition soundings from the high-resolution bathymetry that can help the person who is eventually responsible on the sea bridge to make the final decision. And this is an example of the Charleston Harbor, South Carolina. This is the depths on the available ENC, and this is the high-definition bathymetry derived using the label-based method. Likewise, the uncertainty visualization and integration project that I'm going to present has also aspects that we can use, but I'm not going to get into the weeds of any of these. Third project is the cartographic sounding selection, the final selection of soundings that are used to complement other chart features in the representation of the seafloor. For that, we incorporate the hydrographic sounding selection for generating a secondary digital landscape model of the seabed and extracting its characteristic features. A benefit of using the label-based hydrographic selection is that we do not need to define the neighborhood for the critical point extraction, as this is defined by the label footprint at the scale of the product. Accordingly, we enhance the selection based on parameters such as the maximum allowable deviation from the expected depth. We will continue this effort with making enhancements to this work and with incorporating additional chart features toward a chart-ready sounding selection. The scope of the next project is a simplification of the data quality polygons, our known MQols. This is another project in the theme of our automated cartographic generalization efforts. Currently, cartographers need to manually simplify the outline of the gridded coverage polygon generated by the grid cells containing depths. This is a tedious and time-consuming task where compilers give polygon a more natural shape, and most importantly, need to abide by the ENC 0.3 millimeter point density requirement. We now have a two-step mechanism in place for deriving an ENC compatible polygon. The accuracy is within half grid cell size, and we also achieve the required point density below 0.3 millimeters. However, there is still for outputs review, small artifacts may have been retained like this one over here. We will investigate further improvements to the algorithm in practice to eliminate the small artifacts, but the tool is already in the process of becoming operational with MCD, as it can significantly reduce the time and effort for creating ENCM quads. The last project in our automated cartographic generalization theme is entitled Toward Automated Chart Compilation. This is the holy grail of cartography, the automation of map production. Is this possible? Efforts in the land domain have showed us that yes, this is indeed possible to a great extent. Of course, our domain has specific requirements, constraints if you like, that differentiate us from our land counterparts. The vision is a fully automated solution. However, realistically, in the short term, at least, our expectation from this project is to model the nautical chart compilation and answer fundamental questions towards the end goal. We see this as the foundation, the starting point of many future individual research projects, master's and PhD research topics. Automation, which we discussed in the previous projects, is one of the main challenges we are facing in the workflow, according to our industry discovery project and the responses we have received from professionals in our field from 6 different countries. This project aims to identify the day-to-day challenges in data collection, data processing, chart compilation, research and development, production management, and use of products by the end users. These insights, besides building awareness, can assist in designing new techniques and in evaluating research directions. This figure here shows the identified by the survey participants deficiencies from the first phase of the project that focused on data processing and verification. Besides automation, the industry discovery project identified human and software-related challenges, including that often we don't really know what commercial software is doing for a particular task. To fill in some of the automation gaps or have a better control of the process, the community has developed dedicated free and open software, source software, FOSS. Besides these dedicated tools, there is a plethora of other FOSS for geospatial applications that could potentially help with streamlining the planning to product workflow. However, their use among HOs seems limited. This project is a comprehensive study on the unique capabilities of FOSS and their performance with the aim to raise awareness among HOs and others and identify specific tasks that their use can increase productivity and help our efforts to map the oceans. We conducted an online search where we identified 110 relevant software. This list was filtered out according to factors such as the level of complexity, maturity, popularity, operating system, and functionalities of the software. Potential uses of the remaining 28 pieces of software were identified for further evaluation during an ocean mapping expedition. The opportunity appeared with the Spanish Hydrographic Office and the mapping campaign that took place near the Canary Islands, Spain, as part of the effort for mapping the Spanish exclusive economic zone. The selected software were utilized in the various phases of the survey, and they were proved to be an effective complement to the commercial software used on board for tasks such as line planning, a priori estimation of water column sampling frequency, spotting and fixing artifacts in bathymetry and backscatter, evaluating system performance. The effort will continue with the aim to optimize survey design, troubleshoot and resolve system performance issues, derive products and enhance data visualization and dissemination. Next is our effort to establish and enhance collaborations with maritime academies in the US and abroad. The collaborations have already provided opportunities on both sides to exchange ideas, discuss education programs in both the hydrographic and maritime professions, redirect research and improve products in the operationalization phase, be informed on the development in both professions like S67. So far, we collaborate with MITAC's PMI in Baltimore, US Merchant Maritime Academy in New York, and Maine Maritime. Chart-related maritime accident causes. Maritime accident reports contain a wealth of information that can serve as lessons learned. We can identify chart-related issues, things that we can present better or compile differently, and alleviate the risk for similar accidents in the future. For example, reports demonstrate that data quality as encoded with the zones of confidence are poorly visualized and perceived by mariners, and this can lead to accidents, such as the case of cargo vessel Nova Cura here. In a similar vein, cartographic practices often necessitate the use of a point symbol to chart an isolated danger, such as this one over here. However, the ability of users to change the viewing scale in ECDIS may pose a risk since point symbols scale with scale changes, and this is the example of Pacific. We investigated methods to automate the study of accident reports and the extraction of the required information. This is a project that we will further pursue in the future with the support of a graduate student or external funding. One of the chart-related causes of maritime accidents is the visualization and integration of data quality on charts. Accidents such as the two in the previous slide could have been prevented if the data quality had been better accounted for. This project is trying to find better ways to visualize and integrate data uncertainty in ECDIS. The team has done some work on the integration part, but the previous year, Colin Ware and I focused on the visualization side of things. In the previous reporting periods, we identified the Kadzog star symbology problems, set 5 requirements for the new symbology, investigated the visual variable suitability for the purpose, proposed textures consisting of countable elements as the most promising solution, and more precisely, one consisting of lines and one of dot clusters. We developed in total 5 coding schemes based on the same principle, and we worked on the development of the Mariner survey for the evaluation of the developed coding schemes. In this reporting period, we completed the development of the online survey using the Qualtrics platform. With the support of the 3 maritime academies, the Kings Point, Maritime, and MITAX, we disseminated the survey to professional mariners. Currently, we are analyzing the data for 90 responses that have been received until the beginning of June. This will be used for the peer-reviewed paper. However, the survey is still open and we would highly appreciate your participation. The preliminary results indicate that lines and dot clusters are the most preferred coding schemes in ECDIS, day, bright, and dusk modes. Also, we are working on the development of an in-lab experiment. We expect to run this fall with the aim to further evaluate and make improvements to the coding schemes. For this control experiment, we will be utilizing the synthetic chart generator developed by Colin Ware. Chart generator has the great advantage of generating a new chart-like display on each trial, that is expected to eliminate the familiarity effects in surveys, in experiments. We plan to test the different coding schemes and other parameters of this project, such as the safe route approach we are discussing in the integration part of this project. Last but not least is the Roads of the Sea project. The scope is to assist mariners in safely traversing the seas with a route suggestion and prediction system. Oceans, as we know, do not have roads, but mariners tend to use previously followed routes as best practice. Ships are at higher risk of grounding when they take a route for the first time or stray from a planned route, and of collision when they navigate areas of increased maritime traffic. The Roads of the Sea project aims to assist mariners and autonomous vessels by providing routes customized to the own ship and predicting other ships' trajectories. In this reporting period, we worked on data processing, data structures, cleaning, loading, compression, and others, data structures, heat maps creation, route suggestion, and the development of the system through Amazon Web Services. We now have a first design of the architecture and an implementation of a grid-based customizable route planning system. Unfortunately, though, some development issues didn't allow us to test the system remotely during the Lake Huron expedition that Val presented earlier, as we were planning to do. In the following reporting periods, we will investigate improvements to the above individual parts towards the final goal. Besides supporting safe maritime navigation and enhancing the autonomy efforts in navigation and hydrographic professions, this project may be utilized for uses such as evaluating nautical charts adequacy, setting survey priorities, identifying and planning new maritime traffic separation schemes, and protecting cetaceans from ship strikes. Similarly to the maritime accident project, we will plan to seek external funding for this one. Thank you for your attention. I'm happy to answer any questions you have.
Well, thank you, Christos. You kind of had a mini version of what I tried to do, which is cover way too much in such a short time. But it does demonstrate just how much activity is going on. I should mention that the cartographic activities is something we've really only started in the last few years. And so I think it's really a credit to Christos for how much has been accomplished in such a short time. Well, I hope you've gotten a sense, really it's very frustrating to us and probably frustrating for you, but just a sense of the breadth of the things that go on in the lab. We do have a few minutes, and I think we're willing to stay here as long as you want to take questions if you have them. Some of them might have been answered already, others might not. And so again, you're welcome to just put things in the chat. We can field them there, or just raise your hand or just yell out. I think we're a manageable enough size of a group to just chime in if you have any questions or want to go a little deeper into anything you've heard. And so again, do I start to count now? E, 4, 5, 6. I don't hear anything or see anything in terms of questions or responses. So if that's the case, I don't feel bad. We're at Denny Haynes has a question. Denny, go ahead, please.
Yes, you hear me?
Yes, just fine. Yeah.
Yeah, okay. It's a question for Christos. Was very interested to see all this work and see the progress since the last time we had a chat at the Canadian Hydrographic Conference here in Quebec City in Canada. I think it's already it looks so far. But anyway, it's very encouraging to see all that. I missed a little bit of your presentation at the beginning, but have you had some testing done in simulation centers and places like that where mariners and pilots have seen what you are suggesting and foreseeing and getting their input into the development?
We haven't done any testing on their side, so we developed an online survey for now for the visualization of data uncertainty on charts, the CADSOC visualization on chart of the quality of bathymetric data in S101. But as I said, we will be running an in-lab in situ experiment with the synthetic software, the synthetic chart software that Colin Ware developed. So we are planning to do that. Take the software and go to the maritime academies and do that. Other than that, it was only online so far. But certainly now that we have these collaborations, we will do some stuff with them. That was one of the purpose of the collaborations.
Yeah, that would be very good to get their kind of professional touch into it and find out if it's really fulfilling their expectation in terms of practitioners and users of the system, because this is really the way you'll be able to kind of replace what was called the source diagrams on paper charts, where you were able to see the quality. It is a kind of CADSOC as well, or replacement or better visualization and understanding of the quality of the data, because in areas where you have very low quality or no data at all, you have to know what you have instead of having nothing. Sometimes poor quality is good, but you have to know as a mariners the value of that. And I see what you've been doing is going to help for that. Thank you.
Thank you. Thank you, Denny. EJ.
Yeah, thanks, Larry, and thanks, Christos, for your excellent presentation. It's great to see all the progress you're making, and we've at the Marine Chart Division obviously are very excited about all the activities you have going on. I wanted to ask you in particular about the automated cartographic sounding selection, if you've done any sort of comparisons with a fully human compiled product and what those results have been, if you have, and how they may differ and how they may be similar.
So we have divided the sounding selection into the hydrographic sounding selection, producing a reduced density data set from the high resolution bathymetry. And then we have the cartographic. We haven't done, for the hydrographic, we have done comparison to the existing approaches, which is radius and grid-based approaches. And as I said, we perform best in regards safety and legibility. For the cartographic sounding selection, this is our plan with Noel, who is the main developer of the software. This is in our plans. We will develop, we will run our tools, and we will have your cartographers with their collaboration evaluate our results and get feedback and see where we do well, where we do bad, and improve things.
Yeah, great. Yeah, thanks, and look forward to that. Thanks very much.
Thank you.
Thanks, EJ. Damien.
Yeah, I had two questions for Liz on the acoustic microstructure probe stuff. That's really interesting, and it'd be cool if we can apply it at some point. Maybe I wasn't looking closely enough at the slide, but is there an estimation at this point as to like what kind of uncertainty the calculating a sound speed or trying to modify an existing profile through a calculation from the acoustic determination would give us in terms of like being able to meet uncertainty metrics at multi-beam corrections, or like how that would differ from a in situ measured profile?
Thanks for that question, Damien. That's a great question. So there is if you have enough frequency range, we have a direct connection between the sharpness of the stratification gradient. So if you're imagining two different water masses, how quickly the stratification interface takes you between those. So there's a direct connection between the frequency response and that sharpness. Whether or not we can give you a direct estimate of sound speed from that, we haven't really taken it that far down that road, but you can, in theory, extract basically that sharpness factor, and then from that you might be able to estimate how quickly the sound speed is changing. But the actual two endpoints, I think those would likely need to come from some kind of in situ measurement, at least initially. And then as you move away from that in situ measurement and you use this acoustics, I think in general, the uncertainty is going to grow because the environment is changing, but we can talk about that offline. We're in the early stages of sort of exploring the applicability of it.
Yeah, but if I could chime in, sure. You think about a situation with a sound speed probe, that's a surface sound speed probe that's on the multibeam, that's typically associated with the multibeam. And it may be that might provide one of the endpoints that you can then start moving down and give us the ability to continuously start looking at what we think the sound speed structure would be.
Right. Yeah, I was thinking kind of in terms of a hybrid, right? You have the sound speed profile that you've taken, and maybe you like slowly modify it using the inputs from the acoustic microstructure. But yeah, it'd be interesting to follow that work. The other question was just related, and I'm not sure who's maybe managing this anymore, but the EPOM course that was being taught for incoming ocean mapping students, has that still continued to be revised and or taught to the new students?
Yeah, I'll turn that over to Sema, who turned his camera on perfectly at the right time there, because he knew that question would be directed to him.
It's not been revised, but it's continued to be offered. And I'd certainly be interested in hearing what other modules we could add, or if you have taken some of these modules in the past, how we could update those to better meet the needs.
And I see Giuseppe is with us. So if you want to comment on the EPOM modules, Giuseppe, please go ahead.
I think I will go in the same direction that Sema has been currently just taken not only by students, also by other people interested in learning Python. I had a few requests, also Sema was also getting this request. I think we have a good number of requests coming from people outside the internal students. So I think there is value in these modules, and we will keep adding new stuff in the next months.
Yeah, thanks, Giuseppe. I was thinking of, because I think last year maybe it was presented the kind of survey results of the cohort going through and what they, what their programming level was before and after and understanding. So I didn't know if that had been used to adapt anything. So thanks.
Great. Not seeing any more questions either in the chat or raised hands. I assume I can only look at one page at a time. I assume if somebody raised their hand, they'll move on to the first page. The software has to be that smart. Let me turn to Brian and see if Brian wants to add any comments.
On which particular topic, Larry, or just in general?
Anything you want. As Associate Director, I want to offer you the opportunity.
No, I like you. I am very pleased we have this opportunity to talk to our NOAA colleagues and give them a briefing on what we're doing with all the money they send to us, which we very much appreciate. Like you, I also find it very frustrating to have to do it virtually for the second year, and I'm very much looking forward to being in a room next year, particularly because, to me, I think that's where a lot of the interaction really happens, is the question over coffee. Somebody grabs your elbow and says, hey, listen, can we talk about this? Or that's interesting, what do we do? So hopefully we've given enough of an impression of how much is being done. I would also point people back to our progress reports, which generally get put in mostly on our website, so you can see them from there. But like you, I'm kind of tired of this being a home business. I really like to be in the office. And I look forward to that very shortly.
I think we all agree with that. And finally, let me turn to Andy to offer any closing comments, closing remarks.
Yeah, thanks, Larry. And I'd like to thank you and the other presenters for, I thought, just doing a great job. So thank you for representing us well. I do want to encourage my NOAA colleagues to take this as a starting point for where we go from here. That's I think the reason we like to do this is to get your feedback and where we can go in the future. For example, where do we go in precision navigation? What are the things we need to work on for ASVs? How can we support your educational requirements? I'd like to encourage you as you think about this over the next week or month or so to stay in touch with us and give us some feedback. I see that Gretchen is mentioning cloud support, and that came up several times, and so I think we want to explore how we can serve as a test bed for that, even as we use it in some of our specific problems. So I think that's what I'd like to say, Larry. Thanks.
Thank you, Andy, and you took the words out of my mouth, because this really is, to me, the purpose of this meeting, and I think as Brian pointed out, it often best happens at the sidebar conversations, but it's really to let you know in this super blast, super speed way, all the different things we're up to, and let you explore again if things interest you in depth with people, with individuals more later, and to answer Gretchen's question, I think we do. We've actually already put together a team to talk to you in more detail about cloud support. I think that's probably best to do at a separate meeting. But also probably the most important thing is to really let us know if you think we're off track, and because that could save a lot of time and effort. Sometimes we'll push back. I mean, to be honest, when we first threw out things like Cube, we got a lot of pushback saying that was just the wrong way to go. But I think in the end it turned out to be a very good way.
We were told it was the wrong idea, it would never work, and it was illegal anyway.
Yeah.
Not necessarily in that order.
So we'll push back on occasion, but we really want to know, and that really helps us, and I think helps you in the long run too. And so with that, Tom Weber wants to say something. That's great. So Tom, go ahead. Before I say goodbye.
Can you guys hear me?
We can.
Okay, good. I'm in a weird location. I just wanted to return, and this would, if we were live, I would have raised my hand, but I didn't get to it quickly enough. When Damien asked his first question about, he was talking about the layers and the acoustic reflection from layers and sound speed profiles, and I think that was a really excellent question and an astute application of the work that Liz is doing. I just wanted to throw out the caution that to everybody that was thinking about that, that we're still working on the the how and the why and the physics behind that. And it's not obvious that I think the application is excellent, but it's not obvious that the physics are going to allow us to get there. And so we're still sorting that out. And I think that's a great path to be looking at, but we're early days still. And so I just wanted to make sure people didn't take the wrong idea away. It'd be great if we could do that. We certainly will explore it, but we're early days on just the basic physics behind that at the moment.
Great.
That was the only comment I wanted to make.
No, thanks. That's a very important comment. Thank you. And you're getting to witness often how we work in the lab, that some of us throw out crazy ideas and then Tom comes back and explains the reality and the truth. And Brian plays that role too sometimes.
And Larry, I'd just like to add in that in addition to the possibility of helping us with our mapping mission, I think the extent that we can use our mapping tools to understand the environment gives our mission much more value to everybody in the ocean science field. And so I think it's just one more potential application of the data we collect in the course of our mapping or our other missions. So even if we can't get a sound speed profile out of it, we get a lot of information that a lot of people would be happy to have.
Yeah, no, I can't agree more. Okay, and maybe on that note, let me again thank you all for joining us, and then we'll see you in person for sure next year. Yes? Yes. Thank you all. Bye-bye.